Now it's my pleasure to welcome the Senior School Coordinator at Schadow Gymnasium, Berlin. Welcome, Andreas Gramm.
Good morning. Thank you for the opportunity to give this brief welcome speech here. I teach computer science, and I dare say I've been teaching data literacy for the whole of my professional career. And AI, well, maybe not as much. But as a matter of fact, I was introduced to teaching materials for teaching AI 20 years ago during my teacher training. So that might be interesting. So that was about interacting with the ELISA program of Weissman, creating rules to make up your own rule-based chatbot. So that was interesting. And then now we have neural networks. We used to have them back then, but as we know, they changed. They are more relevant today. So the task really is also to teach that to today's students. The challenge here is how will I teach this? How will I show this? How can I explain this? How can I visualize a neural network? Of course, I can draw a graph, but then networking is about interaction. So is there a way to actually make my students watch how such a model is being generated to understand what the outcome will be that it will later then produce, to actually judge on that outcome? How trustworthy is the outcome? Yeah, and what can I do with it? So to me as a teacher, the key point really is the teaching material and the activities that I can spark and inspire with students. And creating such teaching materials is essential, but by no means trivial. And as a teacher with a full schedule, it really is a challenge to find the time and then to work on the teaching material, to refine it. And I'm not sure whether we should actually leave teachers on their own and every single teacher to create their own material. So we know this by now. We've been knowing this for a long time, that it makes sense to get teachers together and to exchange their experience and also, give inspiration what else they could do. From what I see so far, much of the proposed teaching materials keep the actual AI in a black box and challenge students to interact with AI, show them how to use existing models without really explaining how a model is actually being generated through training. But I was lucky. I got the chance to participate in some of the workshops of the DL project, and I got to know more teaching material and more ways to take a more didactical approach to teaching AI. That was very interesting for me, and I truly believe we need more projects like this to further endorse this. The other thing is, with AI being omnipresent ever since the launch of ChatGPT, the question is no longer just that of how we teach about AI. It is rather, and well, much more, the question of how we teach with AI. And that was not really the case before. So today, AI is no longer just some nerdy detail of some CS class that some students take voluntarily and everyone else is not involved. Instead, teachers of different subject areas explore ways of using generative AI as a tool for teaching. So students learn how to prompt a generative AI effectively. Students receive AI-generated feedback on their work. At my school, quite a few colleagues are getting rather excited about these new tools, and I believe that this development really opens up a unique window of opportunity to enhance teaching experiences. Now, I'm confident that having well-defined teaching approaches like those developed by the DL the TrainDL project will help integrating data literacy and AI into teaching curricula. We talked about this yesterday when we revised the recommendations for policies and all that. So that in the end we can make sure that future generations will not just use data processing and AI, but also understand the underlying principles to make their choices on what to use and what not to use and how to use AI. Yeah, let's make sure that data literacy and artificial intelligence will not just be buzzwords that fade shortly after their rise, but a well-understood, essential key competency for future generations. And I believe for that aim, it needs to be implemented in the curricula to really have its place. Yeah, of course the question is, if you write something into a curriculum, that's the one thing, but how will teachers actually be able to teach that? How will teachers learn about AI and teaching with AI? And how should we teach the teachers? This summit really is topical, so I'm really looking forward to sharing ideas about this in today's talk, in the panel and the workshops. Yeah, being a teacher, I talked a lot about teachers here, but in the end, this is all really about teaching students. So that's why I'm really happy why we have Emilia to join us here for her welcome note. Thank you.
Thank you very much, Andreas Gramm. And as you just said, yes, we will have our next guest, Emilia, in a few seconds. She is a student at a secondary school at the Geschwister-Scholl-Gymnasium in Stuttgart. And I'm really happy to have you here, Emilia.
Can you see and hear me? Yes. Okay, you can see and hear me now. Great. So hello everyone. I'm glad to join you virtually today. My name is Emilia and I go to school in Stuttgart. As an active member of the German Informatics Society, I'm interested in our digital world. And as a student, I will share with you my perspective on artificial intelligence, data, and their significance for education. For this speech, I did a bit of dreaming about how I would like our school reality to look like. The first aspect is using the advantages of AI in our daily learning process. I would say that there is not much that has such a negative impact on the learning process as being under-challenged or over-challenged. Of course, you need to be challenged to broaden your horizons, but in the right amount and at the right pace for you. Responding to individual learning needs and preferences typically leads to an increased motivation and enjoyment of learning. Nevertheless, we have to keep in mind that stronger individualization also leads to stronger monitoring, which shouldn't result in higher pressure to perform. The main function of schools is to prepare students for their future. And in that future, artificial intelligence and data will play an important role. So, what future skills do we need and how can we be well prepared, no matter if we're going to university or starting a job? One of the skills required will be data literacy. So knowing how to handle data sets scientifically. This includes data collection, data management and storage, data cleansing and preparation, data analysis and interpretation, data visualization and communication, as well as data protection and data security. It's not just about handling data. It's also about understanding how data affects AI. The amount, quality, and diversity of data used to train the AI is responsible for the quality of the AI's output. For example, the fact that certain groups are badly recognized by AI is caused by a non-diverse database. One example is the so-called gender data gap. So it's a must to understand how data affects AI. Another important skill is evaluating competency. This includes recognizing, classifying, and evaluating AI-generated content. Is the work created by an AI or a human? If it's AI, does it contain inconsistencies or even mistakes? How is its quality? Can I trust the source? It's important to question and reflect on the content we see. But it's not just that skills are being added. Others become less important. Now that we have the internet in our pockets, as we say, things such as memorizing become less important. And trust me, in today's education, memorizing is a very high priority. So, for their personal, academic, and professional future, students need to learn how to deal competently with artificial intelligence and data. But just knowing how to use them is not enough, in my opinion. In order to really gain a deeper understanding of the digital world, and not only learn how to use tools, computer science education is needed. We shouldn't just rely on fancy tools. We need to understand the why and how behind them, so that we don't just blindly follow what the computer says. It's not just about using the tools. It's about understanding how they work and what they mean for us. To understand the opportunities and limitations of AI, students also need to understand the current strengths and weaknesses of AI. Computer science education also includes digital skills. For example, how do I behave in digital space? So, to summarize, we students want to be properly prepared for our future. And both the use of artificial intelligence and handling data will play an important role in this. I wouldn't say that AI does the thinking for us, but it supports us and our learning process in a new way. So it's a new form of thinking and learning. But for this to happen, we as students have to learn how to use and create artificial intelligence to our advantage, and how to deal with AI systems in a competent, meaningful, and reflective way. For us, it's about being smart users of technology, not just passive consumers. But also, it's about creating applications that shape society and being part of the discourse surrounding modern technology. Only through proper AI and data education, young people learn how to create and use AI technologies responsibly and self-determined. For today, I wish you all a great exchange, and we students, we are waiting for your input, so thank you.
Thank you very much, Emilia. So, now let's turn our attention to today's keynote speech. Please join me in welcoming the Executive Director of the German Informatics Society, Daniel Krupka.
Yeah, thank you, Maike. Hello, everybody, again this morning. Yesterday we've seen how important data and AI literacy is, and how it can be taught in self-effective and attractive way. We've heard from our three welcome speeches from Christine, Andreas, and Emilia how important it is that computer science, artificial intelligence is taught in school. And those of you working here in Germany know that the compulsory informatics in school map differs vastly from federal state to federal state. From 6 hours compulsory CS courses in Mecklenburg, Western Pomerania, until no compulsory elements at all in the state of Bremen. The good news is all our federal states are on the way to introduce computer science compulsory in schools. Even Bremen just announced it 2 weeks ago that from the year 2026-27 on, there will be elements of compulsory CS education in school. And I don't have to convince anybody here, we've heard that a lot, but I just want to stress one study that is really interesting, and we heard that there is a gender gap in general in computer science. There is also a skills gap between the genders in the ICT skills, and a study of the Stifterverband that was released 1.5 years ago makes this point, because in those federal states where you have compulsory computer science education in school, this skill gap between girls and boys does not exist anymore, and it exists in those countries or states where you don't have compulsory CS education in schools. So at least for Germany, I can say that we don't have a problem of knowledge, we have a problem of implementation. And I'm very happy to discuss now or get an input from a European perspective as well as from an US-American perspective. If there's also this, or if the problem lies in the knowledge or in the implementation of these findings. And since here in TrainDL, the project lost my microphone. Maybe I use that. It's easier than this thing here. All right, thanks. Since here in TrainDL, it's a policy experimentation project. We have a little experiment now as well. The format: 1 question, 2 perspectives. Actually, we might have more than 1 question, but we'll state 1 question at a time. Let me introduce our 2 outstanding guests, and I'm really happy that both of you are here. The first keynote speaker, it's kind of a shared and once in a time keynote. The first keynote speaker is responsible for the Digital Education Unit in the European Commission, Directorate General for Education and Culture. He joined the European Commission in 2008, so it has been a while. He knows the business and was setting up the European Institute for Innovation and Technology. In the past, he led the development of the first Digital Education Action Plan, adopted in 2018, and also the new Digital Education Action Plan 2021 to 27, that was adopted in September 2020. Please welcome Georgi Dimitrov. And we have a second guest from the United States. She's the Director of Policy at Code.org, which is a US-based non-profit organization focused on expanding access to computer science education. In her role, she advocates for state-level policies that support K-12 computer science programs, and she's the primary author of the annual State of Computer Science report, which provides a detailed overview of the status of computer science education across the United States. And her work involves not only developing policies, but also ensuring their practical implementation. So please welcome Hannah Weissman. Maybe you sit there for a second, and I'll leave the floor to you in 1 minute. We've said that 1 question at a time, 2 perspectives, and I'm really eager to hear if those perspectives really differ that vastly, or if we might find a common ground. So we brought 3 questions for them, and we'll also open that up afterwards for you here in the room, as well as for you participating online. Each of them will have a 5-minute time to answer each of those questions, and then we'll have the chance to ask some questions. We'll start with Hannah. Already in 2016, Code.org with the ACM and other organizations released the K-12 computer science framework. You just last year initiated something called Teach AI, and the first question you're going to answer is, maybe also elaborate on those two frameworks or initiatives. What is policy-wise currently underway in the area of AI and data literacy in the United States? So please come up here. You can just grab a mic and yeah.
Well, good morning, everyone. Thank you for welcoming me. This is actually my first time to Germany, so it's great to be here and to join such a wonderful guest to compare experiences. And I think it's funny. I think we so often think that our neighbors are much ahead of us, and I think even our initial conversations, there's a lot of similarity, both within Germany, but across the EU, and then in the United States. For those of you who don't know, the United States is very much a state-by-state education system, so that means we have 50 states, and they all do things a little bit differently. So I think to first kind of answer your question, I want to take us back a decade to 2013, 2014. We really started to have a sustained computer science education movement in the United States. And prior to this, there was a lot of computer science going on, there was a lot of technology, but it wasn't necessarily from a sustained policy landscape. And so what that meant is that it was likely because of a teacher being really excited and innovative, or a principal. It wasn't necessarily because the state was prioritizing it. And we recognize that that's not enough, right? If a teacher retires or leaves and it was their passion, and then there isn't that landscape to train new teachers, to get other folks excited, then it dies with them. So Code.org was created about a decade ago and works with a number of partners, both in the United States and then also across the world, to really get a policy landscape. And so that looks like a variety of different things. It looks like things like standards, so teachers know what to teach in computer science. It looks like things like teacher preparation programs. We actually have many states in the United States at the moment where there is no such thing as a computer science teacher. They're actually math teachers or they're business teachers, and they've learned on the job. And I will say, as a former teacher myself, we're always learning on the job, but it's really nice if you get some training and some background. And so that is still something that we're working with. And then our last policy that we came out with about a year ago, which I think really touches on the subject of AI, is actually making computer science, we don't say compulsory, we say a graduation requirement, but it means the same thing, right? That we want every student, when they graduate high school in America, regardless of their future path, whether it be university, whether it be right into the workforce, to have some exposure to computer science. And that really laid the groundwork very well from, I can't believe it's only been about a year that we've had ChatGPT. It feels like a very long time, but when that technology came on board, we already had the really strong computer science foundation. I think we heard yesterday that this isn't a separate subject, right? This falls under that foundation that we've built around digital literacy and skills, understanding computing. And so that really gets to a lot of the efforts right now. So Teach AI is an initiative of Code.org that's providing guidance and resources to policymakers, to school level, to country level, about how do we effectively implement AI in schools. And it's twofold, right? It's for all teachers to teach with AI, right? To make them more efficient, to help give them new ideas, but then also importantly, how to teach about AI. I think we've all talked about the value in knowing how a tool is made, how to make a tool better, what it's used for, what it's not used for. And I think that's a big difference that we're finding around AI opposed to kind of computer science. And so if we go way back more than a decade ago, we've had computers in schools for a long time, but it really wasn't until more recently that we started taking a deeper look. And we said we shouldn't just have typing classes and classes about Excel and Microsoft Word. We should teach our students to program, to create these technologies. One of the things that I'm really excited about with AI is that we're having those discussions in parallel. We're saying we want to get these technologies in the classroom, and we believe that students need to understand how they're made. And I think that's a really important difference, and I think something that we've learned from the computer science movement. one of the things I spend a lot of time in my job is talking about the difference between just computer literacy, right, just knowing how to use a computer, versus actually how to program it, how to create new technologies. And so that's something that I think is a big difference with the AI movement, is trying to have those kind of conversations in parallel. So to your point of what's going on in America around AI, again, certainly very connected to what's going on around computer science. And so we have 8 states in the United States that have made computer science a graduation requirement, and that is going to absolutely incorporate elements of AI, giving those students that exposure to actually how these models work, how to make some of these models. And then we have 7 states, and there's some overlap but not full overlap, who have created their own guidance around AI, and that's something that we're working with all states, and actually even more broader countries as well, to create guidance for schools and for teachers, right? I think we heard before about the need to equip teachers, to give them these tools and resources about when to use AI, when not to use AI, how to develop policies, how to integrate it into its existing policies. I think the last year, right, there's been a little bit of a panic around the education world, and I think an important thing is to say we don't need to throw everything out, right? We need to incorporate AI into our existing systems, but a lot of what we have is really strong, and we have a strong digital foundation. So, you know, we aren't saying that we need completely new standards by any means around technology education, but let's ensure that AI is a part of that. And then I would say, lastly, I think AI has really helped to bring computer science back to the forefront. It has made it even more imperative that this is a foundational skill. There isn't, I think we've talked a lot about everyone sort of already being sold on this, and it's not even just in this room, right? There's a general understanding that digital education, technology, computer science is important, but we have limited time in the day. Teachers are already overwhelmed, and so I think prior to these generative AI tools being accessible to everyone, some folks maybe weren't sure how much time it should be given in school. There were so many competing priorities, and there's very much still competing priorities, but I think this has showed policymakers and school level leaders that we can't wait, and that it does need to be a part of our curricula. And that's going to look different. And I think one of the things that is exciting about America, and I think similar to the EU, is that every state does it a little bit differently. We can learn from each other. We're a little bit competitive in America, so we kind of like to pit each other against each other and see how it works best. But sometimes that looks like in a more integrated fashion. Sometimes that is a more standalone exposure. But I think in general, I'm really excited to see where this continues to take us, with certainly teachers and students at the forefront, right? That is our goal, that we equip teachers to then equip students. And not just to deal with the technologies right now. We're gonna have technologies in 5 or 10 years that students don't know about, teachers don't know about. And so, I know yesterday we talked a little bit about how do you prepare students for a world that we don't know? And there's not one answer, but I think back to the core principles that were actually mentioned in the K-12 computer science framework. Those core principles, they applied 20 years ago, they apply today, they're going to apply in 20 years, and that's breaking down a problem, that's recognizing patterns, that's algorithmically thinking, that's debugging, and then that's evaluating your solution. And those 5 concepts, which were a part of the framework, apply today more than they ever had. And I think that is something that even as we have emerging technologies and even as they change, those 5 concepts are going to be crucial. It doesn't necessarily matter what language you're programming in or what that interaction with the computer looks like. Those are still core skills. So I want to leave it there and kind of turn it over to hear more of the EU perspective, and then, really excited to kind of dive in and hear your questions and see what differs or what doesn't.
Thank you, Hannah. That was really, really interesting, and now I'm happy to hear the perspective of you, Georgi. The Digital Education Action Plan has a priority to enhancing digital competencies for the digital transformation, and I think that is very key. And I know we have a strong partner with you in promoting computer science. So please elaborate a little on what the European Union is planning.
Well, thank you very much, Daniel. Good morning to everyone. Very pleased to be here with you. in Berlin. I have a personal connection to this city. Guten Morgen allerseits, auch an diejenigen, die Deutsch sprechen. So I think that, I mean, you set the scene very nicely, Hannah. Thank you so much for doing that, because as somebody who works in policy, I can say that I agree with almost everything you said. I mean, that's kind of a political answer, I know, but it's true. It's true, because the problem that we are facing here is pretty global and pretty universal. And what I mean by this is that, in a way, you know, it comes down really to the core of computer science and the core of, if you like, the concepts that we speak about. They are universal. It's not about, you know, I come from Bulgaria. It's not about Bulgarian computer science or German computer science. Of course, there are some difficulties, but it's very universal, and that's great, because we are humans and we like to share things which are, let's say, common. But let me give you more the answer to the question, what is going on at the European level, and link it back to what you've said. I want to focus on one word, on what is going on, and the word is, it is awareness. What is going on currently is that there is a much better and higher awareness about the problems that we try to solve with the integration of informatics or computer science in education and training, or with the importance of data literacy, or about the AI competences. You mentioned the AI sort of ChatGPT momentum, but in fact, this has been going on for a bit more than the last year. And this is very good, because we obviously have to snowball on this momentum, and the work that you do with the TrainDL project is a great example of that. So by the way, kudos to those of you who work on the project, because it's very, very exciting. I would give you 3 examples of how we at the European level reflect the higher need for action, and which is basically coming back to the awareness. Because everything you do, which is driven more or less by policy, comes back to a need, and this need needs to be painful enough for people to start to do something. It's actually as simple as that. So the first example I would like to give you is that you probably have heard about the update of the DIGCOM framework. DIGCOM framework is something which has been quite successful at the European level. By the way, I want to make a parenthesis here for everyone that the European Commission does not have competence in the field of education. So it's very similar to what is happening in Germany, but actually a bit more difficult even, if I can put it like this. So our work is primarily focused on supporting cooperation and incentivizing through funding. So these are just closing parentheses. So the DIGCOM framework is a good example of how the awareness raising works, because the DIGCOM framework has been recently updated to cover data literacy, inter alia. Now, I'm aware that there are some critical remarks about what the DIGCOM has covered in its update, whether it's the complete data literacy aspect, including also the use of data and not just the understanding of it. But the fact is that the DIGCOM is used in more than 20 member states of the EU. It's a completely voluntary framework, and is actually coming back to an update with AI and data literacy aspects. Second point, which I have been very involved last year, is much more political, and it comes back to the need to integrate informatics and computer science in education in a much more, structured way. Compulsory or graduation relevant. I don't know what is the right word, but to integrate it as a separate discipline in education and training systems. And last year, we, as part of my work, together with my team, we have been working on what you can have at the European level, which is coming closest to law, which we call soft law. And this is, it's called Council recommendation. Sorry for the jargon, but this is essentially a commitment of the 27 member states to, let's say, work out some of the principles that they agree. And in one of these 2 council recommendations that we have adopted last year after a long negotiation, and very difficult one, I would say, because member states are very jealous of their own, and rightly so, because it's their own competence, their own education systems. One of the core ideas that we have managed to put forward, I believe, is that member states should consider integrating informatics as a separate subject in their curricula. I can tell you that this is not an easy discussion with the member states, because obviously there is a question of competence, and sometimes it's like the Bund and the Länder. They agree on some principles, but sometimes they just don't move towards them. And you can observe it sort of, let's say we're in Germany, so I can say that, no? Very important is that the Commission will follow up on this recommendation, because sometimes you can agree on something, but you need to implement it. And one of the things that we have taken up as a to-do, as a takeaway from this work that was adopted last year in November, is the commitment for the Commission to support the development of a toolbox, or let's call them guidelines on informatics in education. And I think this is going to be a very interesting work. And here I come back to the universal aspect. I believe that there is a role for the European Commission to support the member states in something which is shared across the board, and where there are really not major differences where we can disagree on based on, let's say, cultural or some other important aspects. And here we are going to support the member states in the development of this type of tools, and hopefully we would be able to then bring them more and more to a more structured approach. You mentioned, Daniel, the let's say the differences between Bremen on the one side, and then maybe Mecklenburg-Vorpommern. So I think that it's very important that we move in a more harmonized way. I mean, I'm careful to say that word, but when it comes to the integration of informatics, we should never forget also that this is a very new subject in the history of education. So it's not like there was a tradition of 300 years and then it's taken for granted. We need to actually convince a lot of people that this is of value added. I know that I'm talking to the converted, but okay. So last point I want to finish off with is, again, back to the awareness. I can spend a lot of time in bringing arguments on why this is important, but what is very important for our stakeholders is what the Commission does in order to support them. TrainDL is one example. I'm very glad that this policy experimentation is working very well, and I'm looking forward to the recommendation of it, because I think it was you who mentioned a bit on the exchanges of the teachers. I want to tell you that the Commission has launched, and it is currently ongoing and open for policy experimentations with a priority on data literacy in primary and secondary. And this call in the policy experimentation, let's say, category is the highest of all in terms of the budget. So we consider this to be a top priority. So there are up to 15 million euros in the budget for that. The call is open until early June. And I would like to just mention this and, of course, encourage, because I know that the everyday work of the teacher and the headmasters and the community requires also support, and we are putting forward very specific ways to encourage this. I would probably stop here, and then we can follow up. Thank you.
Thank you, Georgi. That was really insightful. And now we open it up. So if you have any questions, please just raise your hand, or Christine, you raise your card if there is a question from the online world. I'll have a question for both of you. I mean, we as a computer society, German Informatics Society, are also a non-profit pledging for computer science in schools. So my question for you, Hannah, would be, what are you doing to help policymakers in fostering computer science in school? And on the other hand, Georgi, what can organizations, non-profits, as we are, as Code.org is, as there are many outside, what can they do to support you as a policymaker?
Well, I think it's, in some sense, bringing it back to the topic, I think one of the core things that we provide as a nonprofit is data. And so, as I think I was mentioning in your introduction, one of my roles is that I produce a report called The State of Computer Science, and it's the state of computer science in the United States of America. And we are able to say for each of our 50 states what percentage of high schools offer even just one computer science course, and what percent of students take those. And that data is so crucial for policymakers, because I'm able to sit here and tell you today that only 57% of American high schools offer computer science. That is a staggering number in and of itself, and that makes a lot of policymakers sit down and say, only 57%? A lot of them think, oh, we have computers in every school, therefore they must be learning computer science. And then if we dig into that number even further, only 5% of students are taking computer science, right? So even when a course is offered, that doesn't mean that a student is taking it. And then we dive in even further and we say, and let's look at the gender disparities. Let's look at the disparities socioeconomically. And when it is not a compulsory subject, we see massive gaps in high-income students and low-income students, in girls versus boys. And that is crucial for the policymakers, right? There's so many policymakers like yourself who are already sold, right? They already know that data, they don't need to be told it, but there's a lot of folks who don't know that, who are perhaps surprised to learn about the persistent disparities that exist or the challenges that schools have in bringing this subject. And then that isn't even really getting to talk about the emerging technologies, right? And so I think that's a core role that we play as a nonprofit is gathering this information, presenting it to the policymakers, and I think in many ways kind of being that in-between role. You know, as it was mentioned, the teacher or the principal or headmaster doesn't always have that time or bandwidth to bring that data to a policymaker. And so we sort of act as that in-between of gathering that data up, analyzing that data, and then turning to the policymaker and saying, okay, what can we do about this? How can we work with you so it's not just 57% of schools or it's not just 5% of students?
Thank you, Hannah, for answering partially also the question. Actually, I would have said that for us as policymakers, the role of the non-governmental organizations or the civil society more generally, or also companies, by the way, I can put that is really fundamental, especially for my job. Because they are much closer, I mean, they are at the ground. They are able to collect the data or to also partially, I would say, interpret it in much better ways than we can. I also believe that what they do and we find extremely useful is that they do actually what we are doing right now here. This is exactly what these type of organizations can do in a much more impactful way, and I find also in a more effective way, because should that have been organized by the European Commission, we would have a slightly more formal way of doing things, and I'm not sure that that is always necessary when we go down to the problems and the solving of them. You need sometimes, of course, the formal. So it is the data, it is the evidence, but it is also the convening of people who are practitioners and who are working on the field and who are openly talking to each other, including about the real problems that they have. Because as we know, the more sort of formalized you get, also with policymakers, and I am one of them, the more layers of diplomacy you put around what you say. And it's very important that the messages are passed through as directly as possible, because there is no way for me otherwise to understand what the problems are. I mean, I am sold, you are right, but I would like to sort of, you know, get this insight as much as possible and as frequently as possible, because I don't consider myself to be an expert on this. I just happen to find it a very convincing thing to do at maybe the European level. But, you know, in Germany, there is a very nice proverb. I am a big fan of proverbs. So in Germany, there is a very nice proverb which says, you need to leave the church in the village, which is basically to say that you have to let people do their job where they can do that best. And I think really this is what this is about. And so this is where I really, also by the way, with Code.org, we of course we work together. So it's not the first time that we are exchanging on this. Thank you.
Yeah, thank you. Are there any questions? There is a questions in the back. Tilman Michaeli from the TU Munich.
Thank you so much for the input. I was wondering a bit, I mean, we all agree that these recent developments in the field of AI really help us with this course of, like, computing is important, informatics is important, computer science is important. But nevertheless, there is this kind of, like, especially from my colleagues, what I learned from my colleagues in the US, there's this, like, AI education is something different than computer science education. So I was wondering, how do you cope with that, especially on the policy level? Because I think that's a big challenge to, like, emphasize. That's computer science, and that's one part of the bigger thing, we need.
That's a great question, and I think that's a big aspect of my role. So even before AI, there was a big aspect of my role of just educating and bringing awareness of what is computer science. But to your point, when AI came out, right, there was a lot of folks who were like, this is a brand new thing. I've never heard this word before. I've never interacted with these technologies. And so we have a lot of conversations. Well, it's actually not a new thing. Actually, this is not a new terminology. We've actually already been having a lot of these conversations. We've had AI and generative AI for a lot longer than a lot of folks realize. And so we kind of come back to those core principles. We talk about, again, how the models are developed, those underlying computing principles, but we also talk about it from a practical standpoint. So even if you wanted it to be a separate subject, we don't have time for even more subjects. So where does it fit within the curriculum? So I think that is also bringing it to a practical level of absolutely this is important. And we don't want another teacher certification. We don't want a whole another hour devoted to a new subject, because this is a tool that should be integrated into our current landscape. But it has been a challenge. I think there's a lot of very well-intended policymakers whose first thought is, should we have an AI class? And that's been something that we've been both at code.org and then with Teach AI, which is an initiative of code.org with other partners and with many global partners, that we've been working to educate folks on and to try and give them examples of how it fits within computer science standards. The last thing, though, I will say about it is I think AI presents this challenge because it is both teaching with AI, which I would say is more of a technology education, and then teaching about AI. So that is two parallel conversations that we are having. Computer science teachers need more support to integrate this, and all teachers need to understand the tools. But it is something that is really pressing, and I think we're going to continue having those conversations. And I think the more examples we can show of how it fits within the existing school curricula is going to be really crucial to tamping down the idea that we want a whole new subject.
I would like to add just a point. I think it was it you, Mr. Gramm, who said that it's essential but not trivial to implement this? I see totally the point of the AI noise kind of getting over. Totally agree with you, but I do believe that it's one of these hype cycles which will eventually find its way. It's not going to go anywhere, that's clear, but it will need to normalize to some extent. And I think that it comes back to a core proposition that I think it was also Emilia who partially mentioned it. You need to understand what is behind all of these fancy tools, I think she said. But you can say algorithm, you can say whatever you want. And this is the core idea there. And for me, this is why we should keep the focus on the computer science. Of course, we should add the AI relevant competencies or whatever frameworks or anything like this around it. We do this with every other subject, by the way. We constantly update it and also the concepts around it. But we should not, in any case, fully agree with you, let's say, fragmentize further and create even more pressure on the teachers and you know, God knows what. So on this, I just wanted to add this 50 cents.
Yeah, thank you. I think that is good to hear from you as a policymaker, because we're often dealing with these issues. Like for me, we're also having within the GI, we're having this discussion. If we talk about artificial intelligence, people say, yeah, but it's informatics. But on the other hand, sometimes you reach people, they're policymakers, because then they are aware, and then maybe you get to in a dialogue, and then you say, all right, it's not, AI is just one part of computer science. But Valentina, Viktoriya Valentina raised her hand.
Thank you. My question is to Georgi. Actually, you partially answered my question because I was listening about this digicom, that is like fancy words, but it is really meaningful words like digital literacy, artificial intelligence, and you haven't mentioned computational thinking, maybe media literacy, coding, and how we connect this. Actually, you partly answered, but I would like maybe that you highlight what is in this computer science. You mentioned about awareness. Is this right word to connect all these directions that we would like as in schools for teaching, learning, that we would like to see like path where we're going, what's future next year, after next year, integration, maybe STEM also to connect, or what is your vision for next, let's say, 5 years?
Thank you for this extremely good question. I will be short also in the interest of time. I think the way I see it is that all the important parts that you mentioned about the puzzle are really evolving, very fast evolving bits that we need to tackle in education. It just happens that it is so important now to deal with, let's say, AI, and it's a fact of life. I see it as a bit of a moving target, which eventually will need to find a bit more integration. I mentioned the word awareness because it is extremely important for politicians or policymakers. I am a policymaker, but I work eventually for politicians to get started and get going on something once they are convinced, and this awareness is what I meant primarily. But it will be important to not lose sight about the integrative role of informatics. Personally, I believe this is the next best thing we can have around the digital skills development. And more for the society, what I believe we should be primarily thinking of is the role of digital skills and literacy. Of course, we can, delineate and we can define the different parts of it, but there should be also a certain aspect of manageability of all of this, because otherwise it becomes very difficult. So integration going forward of the different bits and pieces, but it needs to be manageable. So that would be my answer to you. Thank you.
Thank you. I've seen, maybe also just introduce yourself briefly. So.
Yeah, sure. I'm Johannes from University of Magdeburg. And the question is more from curiosity. You said now AI or technology is universal. Also, you said there's quite a speed in these changes. And I'm just wondering myself a lot, how does it fit with the regional approach of managing education, so on a state level? Like, is that really holding us back a lot, or how should we deal with it on a long term? I'm not sure if you can answer that. Or
Thank you, Johannes. I will start and I will pass also to you, because America is also, in a way, regional, example. You mentioned it in your... I think you are putting the finger in the wound there, in a way, and there is no good answer to this question. What I see is, again, it's an evolving concept. I will just give you an example. At the European level, if you would have come back 40 years ago, where there was a co and European Economic Community, you would come and you would talk about education. Basically, people would laugh you out. Fast forward, we have a mobility program of Erasmus, which is extremely successful. And the member states have gone through stages of development. I can give you the legal treaties and the different Maastricht and all, and you would see an evolution of how much they accept the idea that it is good to deal with this in a more, I would say, shared fashion. I don't want to use other words here. I think ultimately the education process is a local one. So on this, I believe it needs to also be dealt with at the local level. I think this is where it is implemented. So I don't believe at all in centralization or anything like this. But I believe that especially with the digitalization of the society and, here talking about education, which is affected heavily by it, and also the competences that come out. There is a great deal that we can learn. We can learn from Estonia, we can learn from Finland, from Bulgaria even, in the field of informatics. I was talking to Daniel, and there is a great deal of things we can learn, and this is what we support at the European level, actually the exchange of best practice. And we believe in the voluntary nature of this. But it is a challenge, it is a very big challenge, and it becomes a bigger one by the time, I think Christina mentioned also that it needs to be faster. So, yeah, thank you.
Yeah, it's definitely a hard question. You know, I think from our perspective at Code.org, right, in many ways, I sometimes joke that I feel like I'm working with 50 different countries. And so I think our approach to it is to have these overarching policies, right? We believe that every state should have standards for computer science, and we believe they should encompass a lot of those core things: how computing affects society, problem-solving, critical thinking, and it should be localized to whatever a state needs. Same thing with teacher certification, same thing with graduation requirements. Those look different, and yet that overarching principle we want applied. And then another key aspect that I think is similar that we work on a lot at Code.org is bringing all the states together to share ideas, and not with the goal of making every state identical, but let's take some of those best practices. You know, I think similar in the EU, we have states that their economies differ vastly, and so we have some states where agriculture is still very prevalent, and so their computing education is more focused on the applications in the agricultural sector. I currently live in Boston, and there's a huge healthcare and bioinformatics society, and so there's a lot of focus on how computing is used in that, and that's great and exciting. We would never want to discourage that, and so we approach it from the overall principles of, and then bringing states together to share those ideas. But we certainly want there to be a level of equality, right? Where if a student is in Arizona or in California or in Massachusetts, that they're getting exposure to this crucial subject and that it's being individualized and localized. And, you know, again, I think that's something that's exciting about AI, is a further tool for teachers to help individualize. I think about when I took computer science in high school, and the projects that I were making looked just like the kid next to me, because we did not really have the data as much to individualize, and we were making the same programs. And now I talk to students and they're getting to pull in data sets that interest them, whether it be about art or healthcare. And that is, I think, really exciting and something that we want to continue to amplify. So this idea of equity, but individualization, and then sharing ideas.
Thank you. There is another question, Viktoriya, here in the...
Hello, Hannah. Hello, Georgi. First, thank you for being here and these great presentations. So my name is Ciro. I'm coming from Spain, but thanks to one of those Erasmus Mundus programs, I got quite an extensive educational exposure spanning the US, China, and several European countries. And you mentioned a lot of awareness, and then you, Hannah, you mentioned competition from the US side, and now you mentioned learning from great examples. And drawing from my experience in China, it's very clear that the race on AI is going at different paces from China versus the West, whether it be Europe or the US. Now in China, the AI majors is one of the most popular one, and reflecting back on the idea versus computer science versus AI education, the East and the West are clearly taking very different approaches. So I would like to ask, regardless, I'm putting apart the goods and bads on why those approaches are being taken. I'm more interested on, obviously, whether you, as an organizational, and are aware about this, which I assume you are, and second, putting apart the goods and bads, whether you guys have been learning from cases like China, which clearly are on the lead of the AI race. So yeah, I would like to know whether some of the good things you have learned from it, or you've been taking into consideration when making these decisions. And last, whether we've been talking a lot about West-centered approaches, whether from your end, whether there is specific initiatives focusing to non-Western regions, whether it be the Global South or the West, the East, like China or Asia as a whole? Thank you so much.
I can start a little bit and then turn it over to you. So I think from the very beginning of the kind of digital age, right, there was the ability to communicate more across the world. And when Code.org started, we were certainly more U.S. focused. There was a lot of work for us to do, and we have expanded to more international. And I think that is so exciting because it's two ways. It's not just us bringing curriculum and resources, it's also us learning. And so we operate in every continent except Antarctica. There's no students down there generally. And so it really is learning and going both ways. In particular, we've done a lot of work in Thailand. We have a bunch of folks doing really extensive work in Latin America. There's a big program called Code for Africa that we've also been working on. So there's really, I think, such an exchange of ideas, which is very exciting. I think sometimes it can be overwhelming for policymakers. I think especially if you look at the United States, you want to know what every other state's doing, and then you want to know what the other countries are doing. And so I think there can be an element of that can feel overwhelming. And I also think in the United States, because we don't have a centralized education system, some of the models from other countries are really helpful to look at, and yet they can't quite be applied, because we can't, in the United States, the federal government does not set graduation standards. It never has, it never will. I think somewhat similar to the European Commission, it can incentivize, there can be grants and there can be funds. But absolutely, I think there's such value in learning what other countries are doing, and in particular education systems that look quite different. I think none of us are perfect, right? And none of our education systems can't do without some modification. I think one thing that I would want to call out is I think there's a lot of other countries that have really strong apprenticeship programs and really strong programs for students who are not going to university. And I think that's an area in the United States that we've not always invested in. And so I think that is a place that we're really looking towards. And I think yesterday when some speakers were talking about AI and vocational schools, that is so exciting. And I think that's something that we've not always invested in quite as much. And so I think that is certainly one of the many areas that we're looking towards, whether it be our European partners or Latin America or Asian or African partners, of what does that look like for all students, regardless of what that future is pursuing.
Thank you. So China, and I would say, what are the lessons here maybe for us? I think that there is a great deal you can learn when it comes to the speed of implementation and pace of innovation. And this is something that I think we cannot disregard. And I mean, I think there is a kind of sense of urgency around it. And I think it is there also in European, let's say, circles. We are aware of that. Now, this is about, of course, the AI technology in itself. When I would maybe look at the other side, that has a certain, if you like, cost for society. And it happens that society does not always get asked to let's say, to agree with that. So what I mean is that when you look at application of AI in education, because that's what we're talking about today, education, of course, we can have a general discussion on AI advancement in China, US, or elsewhere, but when it comes to that, it is extremely important to be aware that the application of such tools can, go also wrong in a way that is maybe not done in an ethical and non-discriminatory manner. I mean, we are familiar about surveillance examples from these type of, let's say, places, which are part of the education process. Now, why I'm saying this is because the Commission has put forward Artificial Intelligence Act, which is actually a kind of a global first in that sense to regulate certain aspects of the application of AI on a general level, not in education. But education is a so-called critical high-risk area. And I'm mentioning this because it's a first, and it's basically very clearly pointing to the fact that this is going to be a huge, let's say, process of dispersing AI across the society and the economy. But when it comes to certain places or sectors, such as education, there should be a very great deal of attention to that, because it's not like you can go fast and break things just like this, because I mean, a lot of things can go wrong. So that is what I would say for the AI. And then last point on the examples for the South and the international, everything we do at the European level by default is something that we if you like, share with, especially with, you know, the global South, or with Africa, or with many, many other countries. We have a huge international program. Very simple, the DIGCOM framework is something that we try to promote, for example, outside of Europe. All the aspects that are fairly successful, let's call them like this, we try to reuse them, not to export, let's say, our things, but because we believe that they work, and because there are certain values, of course, attached to them, and for sure, we, you know, we believe in some of those things as part of the society. So, yeah, that would be my my answer. Thank you.
Thank you. Thank you also for the question. I would kind of shift the scope a little towards the teachers, because I mean, it was a central part of this project. We were addressing the teachers, and of course they are a part of the in Germany of the CS community, of the German Informatics Society. But we know it's I mean, Andreas is here, but it's sometimes really hard. They have like a busy, stressful day for them to open up for new ideas, also to, for example, come to such rounds like here, or I mean, we also have our forums, but it's really, really tough to get them out of school, not because they don't want to, just because they don't have the resources and the time and yeah, sometimes also the funding for traveling. So I don't know how you deal with that issue. Is that different in the US? And I mean, that is really far away from the European Commission, because I mean, you got the national states, the federal states, and then you got the teachers who are doing the work on the ground. But are there ideas how we can support them in yeah, picking up the speed?
Great question. So in my work at code.org, we have many different teams, but one of the teams that we have is a team all about outreach and adoption. And so those are the folks who are very much, I spend some time in schools, but those folks spend a lot of time in schools. And so our approach has been, in every state we have what's called a regional partner, and those are generally nonprofits that are based in that state, so they know that locality, and they offer professional development. In the United States, in contrast to Europe, we have very long summers, 12, 13-week summers, so we do have an opportunity to do some professional development there. It's not necessarily easy, though. I think that is continuing. I think particularly since the pandemic, and I can say I was someone who was teaching during the pandemic. It was exhausting, and so the idea then to do more professional development and learning, it's not that teachers don't want to, but they don't always have that time built in. So I would say we have a variety of approaches, and we're still working to refine them. We're continuing to try and offer a lot of asynchronous and online opportunities so teachers can do that at their own pace, with trying to have cohort models, with trying to make sure that teachers have peers that they can talk to. In the United States, and I don't know if this is different in Europe, but in the United States, over half our high schools are less than 500 students. And so in those high schools, you're going to be lucky to have one computer science teacher, so they're not going to necessarily have a colleague. And so that's one of the roles that our organization and other nonprofits we work with tries to fill that gap, is to bring teachers together, whether it be in an online setting or in person. And when we do in person, we try to make sure we pay for all the travel, food, hotel room, try and incentivize it as much as possible to bring those teachers together in a community of practice. You know, when I was a teacher, there was 25 other math teachers I was teaching math, so I had so many colleagues to bring these ideas off of. That's not necessarily the case as much with computer science or informatics yet. I will also say, like, that's a big area where we advocate for more funding for policymakers to make sure that teachers are compensated for their time. So often teachers are asked after school to do more professional development, or on the weekends or the summers. And just as we would want for other professions, teachers to be compensated for that time, there to be money then for substitutes. And so that's certainly a big area where we continue to advocate for there to be adequate resources. But there's also approaches of trying to go into the schools and train teachers during prep hours and do, we call them sometimes micro-credentials, really small bits and units that teachers can digest. So there's a lot of strategies, and it's very challenging. And the schools that need the most support are often the schools that the teacher's already wearing, we say wearing multiple hats. So there may be a math teacher and a computer science teacher, and they're maybe doing lunch duty or something. And so I don't want to skim over the fact that time is a finite resource, and it's something that we are continuing to work through.
Thank you. Well, we try to help them to come together, essentially, because we are, as you say, Daniel, very far away from the maybe from the ground, and we do that by, let's say, means which help teachers come together. What comes to my mind is, for example, the eTwinning platform, which is a online platform which has now more than 400,000 teachers who are cooperating and exchanging, obviously in digital means only. Second point is that Erasmus program is very well known for experiences like yours. I forgot your name, but in fact Erasmus is open for teacher mobility now for quite some time. And even though more than 2/3 of the Erasmus program go for mobility of students, there is 1/3 which is up for projects like that one, as well as for mobility of teachers. So this is very important because actually teachers can exchange in an international environment. And a very recent project, which a third and final example that we did, again, to bring teachers together. That's the only way. We cannot solve the problem of the lack of time. I am aware of that. But I think we can pass the message that it is very important, maybe also to people who have to agree or to compensate, to let's say, incentivize the teachers. And we have a recent project which has received quite a good feedback and attention, which is the Erasmus Teacher Academies. I don't know if anyone has heard, but I would encourage you to have a look at those because they are relatively new, and there the idea is to bring teachers in a very specific subject together. So yes, primarily about coming together and incentivizing them.
All right, since we are kind of coming to the end of at least this panel, Georgi is going to stay a little longer. I think you as well. So that is good. Maybe one last round, one last question. Looking 5 years in time, looking back on now the year 2024, what would you or what would be a wish looking back, saying like that would in like 5 years ago that was really, really good. What happened there that kind of changed something or that brought something new up? Is there something you can think of where you say, all right, there we did something right back then?
Yeah, I think the thing that comes to mind is the emphasis right now that we've been on guidelines and frameworks, and instead of pushing policies top down. I think we've acknowledged at Code.org and at TeachAI that things are changing really quickly, and that we don't, as much as people might want us, we don't have all the answers. And so we really emphasized on putting out these broad guidelines and frameworks. It differs a little bit from our computer science, where because that has been a subject in schools longer, we have more defined policies. And you know, when it comes to education, there's always this tension because you've got kids in front of you and you want to innovate and you want to ensure that they have the best education, but we don't want to go fast and break things. We do not want to use the Silicon Valley approach to our kids in front of us. So I'm hopeful in 5 years that we're going to look back and feel that we moved at the right pace, that we convened and that we addressed it urgently. And we acknowledge that we need to give teachers these resources and support, and that we don't want to shove it down teachers or kids' throats right away, that we need to well equip them. I think sometimes right now folks worry that we aren't moving fast enough, and that there's maybe regions of the world that already have it. But I'm hopeful that we're going to look back and feel that we approached it in a thoughtful way, protecting student privacy. I mean, we've not talked about that yet, but privacy and data need to be protected. So that's what I'm hopeful for. And I think I'll also close that when I took computer science 10 years ago for the first time, I was one of the only girls in the class. And And it wasn't individualized. We weren't talking about AI. We weren't talking about data. And so I also hope that in 5 years, that's not the experience. Our classes reflect the broader society, and they reflect and they talk about the emerging technologies, and they excite students in a way that we haven't always embraced. So I'm very optimistic for what 5 years looks like.
Thank you, Georgi.
Well, difficult to add something to this. I have a simple wish. I would like that in 5 years from now we look at the 20 whatever number of member states, possibly still 27, maybe a bit more, and then there is everywhere informatics, and that we have also sufficient teachers to teach that, and that we have also all the students who can sort of relate a little bit to that, as I call this, universal language. So that would be my very simple wish. You are doing a great job in Germany with the Gesellschaft, so you continue on that, and I think there is a great deal also at the European level that we can do.
All right, thank you very much. Thank you, the two of you. That was really, yeah. Give that to me. That was really, really good and inspiring, and I think we'll have a short break, 10 minutes, 15 minutes, grab a coffee, grab something to eat, and then we'll be back here, and my colleague Mike is going to take over then. So enjoy the coffee.
Welcome back, everyone. Please join me in welcoming my colleague, Maja Denisova from the German Informatics Society. She's working on 2 projects: the Informatics Alliance to introduce computer science as a compulsory subject in all German schools, and Digital Green Talents, a prize for young researchers working on digitalization and sustainability. Maja, the floor is yours.
Thank you, Michael. In the previous keynote, we heard about the approaches in Europe and the US when it comes to digital education. And although, as Georgi rightly said, digital education does not know borders, I would like to zoom in on Europe. As you all know, Erasmus programs and projects like TrainDL make it easier than ever to exchange ideas, learn from, and collaborate with each other. And to quote the European Commission, this exchange is highly needed in order to establish a common vision of high quality, inclusive, and accessible digital education in Europe. But the actual implementation of guidelines and frameworks in European classrooms varies. So where do different countries stand with the introduction of data and AI literacy in the classrooms? And how can we think cross-national when it comes to competencies in these constantly evolving fields? With these questions in mind, I would like to introduce you to our panelists. They bring different perspectives to the table. On the one side, the perspective from inside the classroom in 3 schools in Lithuania, Germany, and Austria. And on the other side, the perspective of the policymakers and public authorities who write frameworks and also implement them. And at the end of the panel, I would like to have a lively discussion with all of you. You're invited to ask questions. And for now, I'm really looking forward to our discussion, so please give a warm round of applause to our 4 teachers whom I'd like to come on stage with me. From Lithuania, an informatics teacher, coordinator, and administrator of STEAM, Fab Lab, and entrepreneurship activities, and winner of numerous awards, including Innovative Teacher of the Year in Informatics and Lithuanian Teacher of the Year. Welcome, Snieguolė. And with you, Vaida, also an informatics and mathematics teacher, who helps with translation into Lithuanian. It's good to have you here. From Germany, a computer science and English teacher who served as examiner for the practical training phase and the coordinator of the senior level curriculum, as well as member of the board of the local group to promote computer science education in the Berlin region. Nice to have you with us, Andreas Gramm. And from Austria, teaching ethics, social and personal skills, history and German at a technical secondary school. In your studies, what I found really interesting, you focused on issues such as machine ethics. Welcome, Maja. Our next guest is working at the State Institute for Schools and Media Berlin-Brandenburg, in German LISUM, specializing in the development of teachers' digital skills. Please join us on stage, Cornelia Brückner. And the last guest is the head of the European Commission's Digital Education Unit, playing a key role in shaping the future of digital education policies and initiatives across the European continent. Welcome back to the stage, Georgi, Dimitrov. So my first question is to you, Snieguolė. You are teaching computer science and have been awarded Innovative Teacher of the Year. What would you say is particular about how you teach data and AI literacy education in your country?
So I speak in Lithuanian language, so very beautiful language. Sorry, but today I speak in Lithuanian. Tai ne vienintelė mokau. Tai aš esu informatikos mokytoja ir bet kokiu atveju labai tuo domiuosi ir mes jau ne pirmi metai apie dirbtinį intelektą kalbame ir mokomės įvairiausių programų su vaikais.
Okay, so between all the other activities as Snieguolė is doing and teaching, so it's not the first year, she is doing for a few years already, teaching artificial intelligence and data literacy, so and trying to use all different apps which are related for teaching artificial intelligence.
Interesting. Can you give us an example of one of the apps? Like what is it like?
Apps. PictoBlocks, very program, teacher table machine, orange tree, and code.org. Yes, code. Yeah.
Thank you.
And more programs.
Thank you. I think you'll all get the chance to try out
ChatGPT,
Google Bard. I wanted to say that you can all try out Orange Tree later in the workshop as well, so you'll get first-hand experience. And Martin, when it comes to data and AI literacy education in Austria, what are the achievements in the field that you are proud of?
Since I'm not teaching informatics, but rather on the contrary, German and ethics and history, probably I'm not that familiar with the topic compared to my colleagues here. But I think what Austria can be proud of is that we have technical high schools. So that's a school I'm teaching at. And in these schools, the students, they are prepared for the job, but also for university. So that's a combination which I think helps them to navigate their future jobs and the world they're living in. And in my school, for example, they have subjects like coding and different other subjects connected to IT, and not just since last year, but in my case, like for the last 2 decades or so. So this type of school, I think, is something Austria can be proud of.
Thank you. And Andreas, you mentioned that it's also important to hear what students have to say. So what do you learn from your students?
Well, my students find it difficult. That's what I learned. They didn't enjoy it as much as I would have thought, because it is a topical topic. But yeah, they felt challenged by the abstract level of the ideas. Well, I try to help them, of course, as a teacher, but I'm not sure whether I actually succeeded that much. What I did like is I found a poster created at the Freie Universität Berlin, which was a part of the TrainDL project, that actually gave an overview over the different types of machine learning, and I used that a lot, and I felt this helped students actually see, okay, we learned about supervised learning, we learned about reinforcement learning, and to actually bring this into perspective of the whole range of different kinds of AI, and that itself is a learning goal to me, that they see AI as not just the one AI idea, but that it's a branch of thinking in a way.
Sort of break it down into numerous fields and then visualize it.
Yeah, I really liked using hands-on material, and I felt that this really helped them. And whenever I found such material, I really had the impression that they could grasp the actual idea of this type of artificial intelligence, and that they could reproduce the ideas and actually then talk about it as well.
Mm-hmm. Thank you. And Georgi, you mentioned a few countries earlier. Can you give us an example of a concept of how data literacy or AI literacy is taught in a classroom that you think has been implemented in a very good way?
Yes, the expectations are very high, I think, here. Thank you for the very tough question. I have to say that from my perspective, there is not as sufficient evidence to say, this is a well-established way to do that, and this is what I would say is a role model. Maybe because it is relatively new, maybe because it is so fast moving. I'm not quite sure myself. I think that what I have seen so far are some interesting ways to do that. For example, in a country like Estonia, I have seen some very interesting examples of how they implement it. In the Netherlands as well, I have seen quite some promising examples. I think it has a lot to do with the freedom of the teacher and the autonomy of the teacher to take certain decisions. Sometimes the learning material that you get, and I think you mentioned it earlier on, already gives you a structure of what you can and you cannot do. And if the learning material is, I would say, rigid and maybe not as attractive to the student, then you can do whatever you want, but it will be much more difficult to implement it. So I also think that it's a combination of the quality of the material, of the autonomy of the teacher, of let's say the system, and I think that it's very difficult to say there is one country which does this very, very well in Europe. On the contrary, I think that if you bring different teachers like here today or in some of the other projects that we have, you see that in different geographies there are very, very different successful examples. And I, as a person who deals with education policy in Europe, I always, I'm also a little bit also careful to say this is the one example that we should follow. You understand probably why. I also don't think it is the case anyway, but yeah.
The right answer would have been Germany. No, I'm kidding. So Cornelia, you have been part of TrainDL for the last 3 years. And my question to you is, why did you participate with LISM as a project partner, and what did you learn?
Well, let me give you a short answer. I participated because I was asked to. So this is the way things work sometimes here. But I have to say, for me, I profited very much from TrainDL because it gave me the opportunity to really work together with partners. I'm not working together on a daily level. So I had really good experiences with working together with the TU, the Freie Universität, for example. We had very practical meetings. We had meetings which helped me a lot also to design courses for in-teacher, in-service teacher trainings, and also the exchange on a European level. So I got the chance to go to Lithuania, to talk to you, I had the chance to learn more about your educational system, and these are really valuable experiences for me as an institution, because our institution is, it's a bit sad to say this, but we are a little bit closed, we are working on a local level or federal state level, and I do not get often the opportunity to go outside and have these kind of collaboration and joint working groups with universities and other experts. So yeah, I'm very grateful for this experience, actually. And I could really profit from it, because we implemented some of the course material that was developed during TrainDL already in some of our teacher trainings.
Thank you. And a question to all of you teachers. How does the digital education look like for the teacher training in your country? How is it structured, and how often do you have to do it, or do you find it?
Mūsų šalyje iš tikrųjų daug vyksta mokymų mokytojams ta tema, ir mokytojai įsitraukia į tai, aišku, yra kai kuriems sudėtinga ir labai nauja viskas, bet mokomės, šviečiame, sakykime, tą linkmę, ir tikiuosi su bendrai žiūrint į ateitį, sakykime, kad turi būti mokymai, turi būti kažkokie integracijos pokalbiai, kartu etika, būtent kalbėti apie problemas, kurios gali atsirasti, sakykime, su dirbtiniu intelektu, ir turim suintegruoti.
Okay, so I'll translate what Snieguolė mentioned. So actually in Lithuania there are quite a lot of seminars for already in-service teachers, and about digital education, and also she said if to look on the perspective, it would be good that there would be also not courses about artificial intelligence, not only on technical perspective, but also from ethical view, that we had discussions on ethical, how to live with artificial intelligence, how to deal with that. And now I will add from myself, actually this morning from 8 a.m. I had a lecture for pre-service teachers about artificial intelligence and data literacy that we are prepared material during TrainDL project. So those primary pre-service teachers already got some teaching this morning. So thank you.
That's good to know. Thank you. How is it in Germany and Austria?
In Berlin, we have teachers doing teacher training for in-service teachers. So there's a group of teachers here in Berlin, and they offer courses in the afternoon, which are free, and you can easily book them and register and go there. And most of these teachers are also organized in the GI, in the local GI group, so that makes a perfect Venn diagram. And as the local group of the GI, we also organize like a day of training, which is in a way special, because that is not the way it's meant to be. It's the exception from the rule to actually have teachers to be free for a day to participate in a training. And that is very important. We actually do 2 days a year, one set up by the GI and one set up by the group of people who is then the same group of people, but actually with the head of those offering teacher trainings. Yeah, so what I would wish more would be more flexible ways to actually organize such teacher training for a whole day, because that is much more efficient than meeting in the afternoon after giving 7 lessons maybe and having 7 more lessons to prepare for the next day. So that really opens up people's minds and is much more effective, I feel. And I see a great level of support on the level of the school. So whenever I ask whether I can go to a training, it's always a yes, and people are very supportive. But I would, I would wish it were more supportive on a structural level. So it really always feels you have to ask for training and rather justify that you need training, which should be given for granted.
And Cornelia, maybe a direct question to you. Is it something that your institution can maybe change or have an impact on?
Yes and no. Well, we talked already about this this morning, that time is a very relevant factor. And we offer different ways for teachers to profit from training. So we have online courses, we do in-school teachings, we very much support also the teachers come together, let's say, from several schools, so but also in school that they create teams to have maybe like something like micro teachings and things like that. So this is something we can do to give them more opportunity to have trainings, and not always these long trainings, but maybe just an hour or exchange possibilities to get some exchange between teachers from different subjects or even one subject together. This is one thing. But on the political side, yes, we would like to have something like fixed opportunities for teachers to go to training, so that they have really time for this and even be compensated for their trainings. And also to make it maybe compulsory to attend trainings, because it's not at the moment. So we have also some teachers who don't attend trainings because they don't have to, and sometimes they don't want to. So this is one point I would put forward, to have, throughout the year, a certain amount of teacher trainings that can and should be attended by teachers. And that's something we are, campaigning for, but it's different. We are, on a federal level, and we are in constant communication with other authorities, but that's something I would wish for to happen, that compensation, and that there will be time for teachers to attend teacher trainings.
And Georgi, is that something you can also think about in your guidelines to take on, that you considered already, or is it something that's more on the national level?
Certainly, it's something more on the national level, but nevertheless, we are strongly recommending the member states in what I've mentioned earlier on, the council recommendations. By the way, I very much agree with what both of you have said. I think that just like you don't need to be, let's say, so visionary to come back to this conclusion, because in every job you need to do this. So why wouldn't you have this also in the super important job of the teacher, where you really are given the time for it, you are also encouraged. So it's really like a no-brainer to me, and I don't understand, to be honest, why there is still these difficulties to bring that message across. I also think that when it comes to the digital part, this needs to be compulsory, and I think that, of course, now I'm happy to hear other views, but depending on the level of specialization, there should be a compulsory part for all the teachers, because this is part of the let's say, the teaching and learning process to some extent. I'm not now referring to computer science for everyone. I'm thinking more about more basic type of digital skills, which should be compulsory for all the teachers, and this is exactly what we have said last year in the Council recommendations, and the member states have agreed to that. So we will remind them now in a regular basis, every now and then, and certainly we will get there, because it's probably just a question of implementation and time, rather than being the right thing to do.
Thank you. So hopefully in the next years, this need or wish will be fulfilled. And how does it look like in Austria, Martin?
If I'm allowed to react to one of your points, I was trained as an ethics teacher just recently, and there I got the opportunity to work on topics of machine ethics and data literacy, which I was quite happy about. It wasn't compulsory though, because we had the chance to choose from different classes or courses. But a lot of my colleagues took this opportunity, and from what I remember, studying history and German, the digital humanities started to get the attention they need, probably like 10 years ago already. But still for my subjects, it's just one piece, and informatics is a separate subject in Austria, so you can study that and focus on that, but also in the other subjects, I think it's something which is already at some, or for some degree, implemented. But yeah, in general, when it comes to training the teachers, probably the situation is similar than it is in Germany.
Thank you. And now I would like to ask you, Georgi and Cornelia, if you have any questions from your work that you would ask to the teachers that are in the classrooms, what interests you, what could help you maybe in your work?
I have for sure a lot, but I'll ask only one. For three of you, let's say what is the single biggest problem when you maybe a little bit less for you because you teach other topics, but please feel free. What is the single most important problem that you face when you teach, let's say, computer science or AI in the school? Is it something structural in the school, or is it bringing this across to the? So where is the most time that you spend on? And maybe for you, from the ethical perspective, if you would have to explain the digital world in an ethical, what is the challenge there?
Right?
Yeah.
No. I doesn't have problem, but yeah. Bet gal mokinius sugalvoti tokius gyvenime, ta prasme, aš kai mokau, kalbu apie dirbtinį intelektą, ar ten, sakykime, kažkokią programą mokomės, tai man labai svarbu sugalvoti tokį kaip pavyzdį, kur tai taikoma gyvenime, kad vaikai suprastų, kam to reikia, kodėl aš mokau tokį dalyką, taip. Tai labai svarbu tas toks sugalvojimas to pavyzdžio, kad suprastų, kam to reikia.
Like Snieguolė mentioned to me personally that she has no problems, but what she thought that was that for her is very important when she's teaching artificial intelligence or programming and so on, to find the examples from the real life to the student, that they fully understand that why should I learn this, where I can use later this on, so that really from how this works in real life, where I can adapt this stuff which I have learned at school really practically in the real world.
Jeigu, pavyzdžiui, na, imant veidų atpažinimą ir kaip mes mokomės atpažinti daiktus, veidus, tai aš imu pavyzdį, kaip mano telefone, na, atpažįsta mano veidą, na, ne visada atpažįsta iš tikrųjų tą veidą, žodžiu, kažkaip tai blogai veikia, bet tada, na, susieja tą informaciją, tai va čia su to telefonu, žodžiu, su veidų atpažinimu. Tai.
Okay, so if one concrete example, for example, if they are learning image recognition, so let's take concrete example, face recognition. So she takes a smartphone and then she shows that there is like a security rule that he has to recognize my face and then to unlock. And the students see that, yes, the image recognition is practically used, for example, in the face recognition in the smartphones for the security reasons. That's
a very good example, and you would wish for more things like that to just have a framework.
Yeah.
Thank you.
I would say that my biggest problem is that most of the students that I would like to teach actually don't show up in my classes. So the topic of informatics for all, we talked about this earlier, but that really is one key. If I don't get to teach the kids, I have no chance of talking about these ideas. But for those who do show up, I've found one thing challenging of keeping track of the new tools and what is there and how I could teach that. So I do spend time in teacher training, but things develop so quickly, and whenever I get to see new tools or I hear from colleagues, or we talk about this in between lessons a lot, and every now and then you get to learn about a new tool, and which is really exciting. So, but there's no real structured way of exchange, I'd say, to have access to these things.
Mm-hmm. Thank you.
Yeah, one challenge for me, probably since the launch of ChatGPT, is how to, I don't know if you can say it like that, but how to navigate or manage the hype in class. So, and not just when I work with students, but also when I work with colleagues. So on the one hand, you have the people who are very, very worried and skeptical, and on the other hand, you have the ones who are, very optimistic. And sometimes it's difficult to find a middle course. So at least that's what I try to do, because I think that's important. And maybe also to, you mentioned Weizenbaum this morning, and I think he was one who promoted to demystify AI, and I think that's something very important at the moment. So that's a challenge for me right now.
One thing that I found challenging is actually creating tests on the topic of AI, so to measure student learning. What I found out for me is that questions remain much on a descriptive level. So I introduce concepts, and in the test I will ask them to describe or explain concepts, whereas normally I would then move on to the application of knowledge. So that to me was challenging. I'm not saying it's not possible, but I found it challenging to then move on. I don't know if you can ask them to sort of create their own language model within a test. That's probably not the way.
And out of curiosity, how do you address bias, Martin, in your classroom when you teach ethics?
If it comes to biases, I think it's an easy way to find similarities outside the world of AI, I think. So we have biases not just in informatics or in coding or in AI, but also in everyday life. And to answer that question, that's the way to go for me, to find these similarities.
And also in the Computer Games Museum that we visited yesterday, there's the ELISA of Weizenbaum, so it's also a way to show the students. And with that, I would like to open our discussion to the audience. So if you have any questions to one of our panelists or to all of them, please feel free. Yeah.
Well, is it no? Okay.
Maybe this.
Is it working now? Yeah. Okay. I'd like to ask one question. Maybe I'll bring forward let's say, a controversial point to all of you, and maybe also to the audience, because we were talking today in the morning about not going forward and not breaking things. But I was also thinking, why not? Because does AI have maybe a transformational power for our educational system? Because our system now is maybe oriented to output, knowledge, and let's say repetition. And these are things that are now put into question with the application of AI in our classes, in the schools, and educational systems. So maybe shouldn't we put more attention to the learning process, more attention to maybe also critical work, and also like nurture human intelligence, whatever that might be. But this is a question I was asking myself yesterday and today. So do you think, is there a transformational or even, let's say, disruptive power to AI when talking about our educational system?
Whoever wants to start first.
Well, you said earlier that you find it challenging to find examples where where students can actually see the benefit from learning something, and I do believe that we will have to justify this even more in a time where you can ask ChatGPT to code an application. So why should I learn to code if it does the job for me? Somebody has to know what to ask an artificial intelligence in order to get things. So I think you have to have some concept of what you're asking for and what it should be, even though in the end you might not still be coding. I mean, people use things like Copilot in software production today, so it's happening today. Professionals are using this. These professionals have been trained and know what they're asking for and judge on the output and probably adjust the output in parts where they don't agree with what the AI produced. But that is something that we need to make students aware of. And so I do believe we need to explain more why students should learn that.
Yeah, I also think that you have to become aware of the relevance of your subject, because these are questions students will ask you, not only you as an IT teacher, but me as a German teacher. Why do I have to write texts if ChatGPT is much better in it? And I think that's not a very difficult job. And I also think that since we focus on competences and since we focus on critical thinking, at least that's what I try to do, and I guess we try to do. The introduction of large language models wasn't that much of a game changer for me in class, to be honest. But you have to know what the relevance of your subject is, and yeah, for my subjects, for example, one answer could be to focus on critical thinking.
Aš galvoju, kad bet kokiu atveju keičiasi mokymas, keičiasi, sakykime, bendrai keliaujant diena iš dienos, ta prasme, viskas keičiasi bet tai nereiškia, kad pakeis ir tai bus kažkaip kad tai bus pakeista vien dirbtinis intelektas, sakykime, pakeis ir mums nereikės ten tų mokytojų ar panašiai, bet kokiu atveju mes turim skatinti vaikus kritiškai mąstyti, priimti tą informaciją, plus turbūt, manau, integruosis turbūt į tokį tarpdiscipliniškumą pamokose visą tai. Ir aišku, kad mes parašom ir kaip sakot, ir kodą parašo mums ChatGPT ar kitos dirbtinio intelekto programos, bet tai nereiškia, kad tas vaikas išmoksta, jisai turi taip turėti tas, kaip ir kolega sakė, turi turėti tas pradinės žinias visų pirma, kad suprastų, ką ten rašo bendrai. Ir svarbiausia turbūt mokėti tas žinias pritaikyti, kurias jau tu gauni kaip ir iš tų programų.
Okay, a very long answer, so I'll try to remember what Snieguolė have you said. So first idea is that, of course, artificial intelligence is changing the learning process, so it will be different. Maybe it will be more integrated in different subjects, more interdisciplinary, but if we could say that for the knowledge it will change teachers, of course not. And for the teachers' purpose, like also colleagues mentioned, to teach critical thinking, to understand that artificial intelligence is not providing pure, trustful knowledge. And for example, like colleagues mentioned, if you are not programmer, but ChatGPT writes a code for you, then of course you will not become a programmer, but you have to have your basic knowledge. Then you can use it as a tool, and then it can be helpful for you, because with the zero knowledge it is not useful.
I'm glad to hear that critical thinking seems to be like the consensus of everyone. And my question is, how much of large language models are in the new EU guidelines? How is it handled in the European Commission?
Well, they are not at all, because there are no the guidelines that are adopted now, I wanted to mention them. In fact, we had such a perfect timing that we published them in October, and ChatGPT came in November. So obviously we did not cover this, but we had specific information on how you deal with tutor-based, let's say dialogue-based systems, or, I mean, actually what you have in ChatGPT. By the way, this is also available in all European languages, also in Lithuanian, and it is around 40 pages long. I think it's a first attempt to give something practical to the teachers. I should have mentioned the title. It's Ethical Guidelines on AI and Data Usage for Educators, and published in October 22 by the European Commission. I guess this is what you're referring to, those guidelines. Yeah, because on the informatics one, we are currently working towards setting up a independent working group of European experts, and we will have probably, hopefully, also a few teachers. And we want to set up this process and develop informatics guidelines for education, how member states can be better supported in running some of these processes, because we know that some of them are more advanced, some are less advanced, and the idea is to bring them together, around 20 people, to work over 1 year, and then at the end of the day there would be guidelines on informatics education adopted at European level. So maybe just to give an example of how practically we would work.
Great, thank you. Anyone has questions? Also, if you have questions to Cornelia and Georgi, feel free.
I would have one more answer to Cornelia's question. A student of mine is actually preparing a presentation on the question whether artificial intelligence will be able to replace teachers and whether we want that. So she's also considering the ethical side of things. I haven't seen the presentation yet, but I'm sure this will be an issue. I don't think we will be replaced soon. I don't think we should be replaced soon. But I do believe that the way we teach is going to change, and probably parts of what we do can be done or will be able to be done through AI, but this might give us then resources to focus on other things like explaining more or tutoring students who experience difficulties.
Thank you. Any questions from the audience? Yes, please.
Thank you. Good morning. Thank you for sharing your viewpoints and experiences. I would like to follow up on Cornelia's question, whether I understood it to be something like this. Is the introduction and the disruption caused by AI a wake-up call for change in educational systems? So I would say that educational systems receive a lot of wake-up calls, but they will only listen to it and change because, of course, they don't have a life of their own, if their agents are constructively aligned. And this requires a lot of political work and also theoretical work to happen. And trying to see into this possible future, I would like to ask the members of the panel about two aspects. First, if there is some kind of alignment in your experiences among items such as data literacy, but also discussions that were present before, such as media literacy and fighting fake news. And the second question is about the alignment in a vertical manner of stakeholders. So I would like to ask the teachers what kind of policy, and if we can say a curriculum reform policy, they would like to have, so it would support you in dealing with these aspects at school.
Thank you for this question. Anyone wants to?
Okay, so yeah, it's a complex question. I'll answer the question of the alignment. Of course, we are working on this. You have to maybe distinguish between different levels of action. We talked a lot about today about the local level, what's happening with workshops in teacher trainings, etc. Then we have a more like intermediate level, which is represented maybe by my institution. We try to have a dialogue with other institutions in federal states. We try to have a dialogue with university, with expert groups to maybe agree on something like a core program now to have to do teacher trainings about AI. So what is important to know, maybe also to give this kind of more structured way to do these things, because a lot of heterogenic things are happening right now. And then also to give teachers guidelines about legal advice. Is it okay to use ChatGPT in the classroom, for example? And also to give them support in all those questions. How can I talk about AI in the classroom? What is important, what's not important, so on and so on. And then there's a third level, which is, speaking for Germany, there's the state level. So, and responsibility of the state level is really to give us guidelines on what's important and what will be the goals. And one of the goals is, and I think this is also very important, must be to have AI applications specific for education, so that we do not have to rely on commercial products, for example. So this is very important to get initiatives going to develop these kind of tools that will be implemented or can be implemented in the school system. So I think these three levels, they in a way have to work together, and they do work together. And this is also something I'd like to highlight, that I see a lot of exchange going on right now. I'm in communication with other institutes. Even the state level institutions, I perceive a strong will to move forward and to act quickly, which hasn't been the case in past times, I have to say. And this is something for me, it's very positive that these things, finally they come together and I see a real will to change things and to make things better.
Thank you.
Your question. Lithuania have this program, but galbūt, kaip sakom, įrankių daugiau reikėtų būtent įgyvendinti tą programą.
So as Snieguolė mentioned, Lithuania from this school year, we have renewed our curriculum, all the curriculums, and also on computer science, and there are those topics like security and artificial intelligence and data literacy in the program. And we have compulsory subject from 1st till 10th grade, and in 11th and 12th grade, they can not very alternative, yeah, we can say like this, select from the science group one of the subjects. So these really are, but we are still missing, like Cornelia mentioned, we're still missing tools, what we tools can use for teaching and learning with these, yeah, free tools.
Thank you. Georgi, you wanted to add?
I can say something about the alignment. I think that maybe I see it a little bit differently. I think there is definitely the momentum. I here can totally agree with you, Cornelia. I think the alignment is more on the problems that we already have seen, and you mentioned it yourself, fake news. I think by now this is a bit of a identified issue that many people understand, and understand why digital skills and literacy is important to fight it. I'm not so sure about AI. On this, I'm not quite sure that we are yet there, that we have, and I'm talking about a societal perspective, because you mentioned yourself you need to have concerted action, you need to have politicians who are on board, because it doesn't help if the converted here do something, whereas on the top there is nobody to support it. So I'm not quite sure about the alignment on AI, and I see there a lot of discussion going on. That's why I think legislation is important in terms of the AI Act, the European regulation on the AI Act. And I think that we will have to ask, coming back to the point of the content and the tools, I think we will have to ask ourselves, in order to achieve that alignment, which I think eventually will also come, because we will realize how important that is, also at societal level, we will need to ask ourselves some questions such as what European models do we want to have, what kind of tools we want to use in Europe. Are we comfortable with outsourcing all of it? Are we, okay to be not in control of the data? All these questions we'll need to decide for ourselves, and then maybe the alignment that you're mentioning would sort of come up. But I don't see it yet. I think that there is a lot of confusion, and it starts with a basic question by a teacher: what do I do about ChatGPT in my classroom? I mean, you basically see it. It's just obvious. So I hope that we will together also, maybe on our level, we can contribute a bit to that discussion. But I feel we have some very, very interesting questions to solve first in order to get there.
Thank you very much. And on this note, I would like to end the panel because our time is running up and the lunch is already waiting. But thank you so much for all the interesting topics. And I think we can continue to have these conversations in other conversations. And with that, I give over to Maja.
Yeah, so thank you very much, dear panelists. Yeah, you can. Yeah, sure, you can sit. I will just please take the time, take your photo. No, it's fine. Because after the photo, I would like to invite you all to take lunch, and we see each other again here at 1 for the teaching materials workshop.
Thank you very much. Thank you.
So, welcome back, dear guests online and on site. I hope you had a nice lunch break and some nice discussions. So we are now moving on to the teaching materials workshop. Following the presentation titled Bridging the Gap, Empowering Teachers in AI and Data Literacy Across Europe, we'll explore the teaching materials that have been developed in TrainDL. Our program then concludes with a talk on the evaluation of the teacher trainings. So please welcome for the first talk 2 speakers from Vilnius and 2 speakers from Berlin. From the Computer Science Education Research Group at Vilnius University, Professor Valentina Dagienė and Vaida Masiulionytė-Dagienė. Welcome. So please take a seat. And from the Education Research Group of the Institute for Computer Science at Freie Universität Berlin, Viktoriya Olari and Zoppke. Welcome everyone, the stage is yours.
Great, thank you. Very warm welcome from us. Thank you, Maja, for the introduction. Good afternoon. So far, we've been talking a lot about the policies, why the teachers should learn about AI. And in our part, we are going to talk about the actual teacher trainings. So today's workshop will consist of actually 3 parts. So in the first part, we will talk about the teacher training and teaching materials. The presentation will take around about 20 to 30 minutes, so you can relax, sit back and enjoy the presentation. Then you will have the chance to get some coffee, and in the second part of the workshop, try out some of the materials that we have developed. And after that, there will be another break, which is not on the slide here, but my colleague Martin is going to talk about the evaluation results. So how do the teacher evaluated and rated the teaching materials on their applicability for the school, for school teaching. Here you can see the people who were primarily responsible for the development of teaching concept and teaching materials, the core team, so to say. Here today are Viktoriya, so it's me, and Till from the Computer Science Education Research Group from the Free University of Berlin. And we were primarily responsible for the development of teaching materials for computer science teachers and STEAM teachers under the guidance of Professor Dr. Ralph Romeike. And then yesterday you met Valentina and today also Vaida. They are from Vilnius University and they were responsible primarily for the development of primary teaching materials and the concept for the primary teachers. So they will give a brief introduction on the materials for primary teachers. So let's dive in. At the beginning of the TrainDL project, and I want to take you a little bit back into the history, it was the year 2021, we asked ourselves in the TrainDL project, okay, so what is actually, what the teachers should learn actually about AI? So we have on the one hand the requirement teachers should learn about AI because as we heard yesterday and today, AI is everywhere, it's changing literally every single discipline. AI is coming into the school curricula, into the policy recommendations. But on the other hand, what is that content? What is that about? What do they actually need to learn about AI? And so at the beginning of the project, we did several literature reviews on the field of AI education. We reviewed different frameworks. We also reviewed the policies that Martin was talking about yesterday. And believe me or not, the number of publications in that area is growing exponentially. Like for the last 10 years, probably every year, there is a huge number of resources, also educational frameworks. It's really a lot. So we found actually a wide variety of proposals. what could be the content, but interestingly, the most of things, they were for the school's teacher, for the school students, like what the school students should know about AI, and also the general public, not so much for teacher education. Nowadays it's changed, so nowadays we have some more pedagogical models, but back then in 2021, we didn't have much pedagogical model that we could refer to, or the content, like the overview of the content, what are the key concepts. And so, but we found a lot for school students, and we looked at that, like what the school students should actually know about AI. And one popular model back that day, I mean, it's still popular, very popular today, and referenced by many researchers, is a model developed in the US by a group of researchers, industry experts, and also teachers. And it suggests that every school student should know these 5 big ideas on AI. They need to understand these 5 big ideas. So the first one you can see in the top. I see if this one is working. Let's see. No. Okay, but you can see at the top, the first one, under the number 1, it is perception. So that the computers perceive the world via sensors. So this is the first big idea. The second one is about the representation and reasoning, how the computers represent the world. Thank you. The third one is actually, the third one is actually about learning, and the idea that computers can learn from data. And actually today and yesterday we talked a lot about data, right? So that the computers learn from that data. The fourth idea is about natural interaction, what is needed for computers to interact with us humans. And the fifth idea here in the middle is the societal impact, which actually say, okay, AI can impact society in both positive and negative ways. And for these 5 big ideas, there were a huge competence framework developed for school students, beginning from the pre-elementary school, elementary school, until the high school. So it was a very pioneering work that has been done in the US by researchers and industry experts and teachers. In the European in the European context, we have, yesterday, the Tillman also was speaking about the Dagstuhl triangle. So we quite often reference the Dagstuhl triangle when we speak about the content and competencies that the students need to learn or acquire when they learn a new technological content area. And then back in 2021 and 2022, Tillman, Stefan, Reger, and Professor Dr. Ralph Romeike, they published recommendations for K-12 students on AI based on this idea of the Dagstuhl triangle. And you can see there are these 3 perspectives. So we have here on the left-hand side the technological perspective. So how does the technology work? Then on the right-hand side, we see the social cultural perspective. So what are the effects of the AI technology? And then here below, the user-oriented or the applicational perspective, where we ask ourselves the question, so how to use these technologies. And then back to these days, there were, Tillman, Stefan, and Rolf, together with many teachers, computer science teachers, they defined several areas, several content areas, and also to every content area, the competencies on what the students can learn about the artificial intelligence. And then you can see, for instance, on the technological perspective, we see different big topics like applications of the artificial intelligence, but also approaches to the AI, such as machine learning. So a lot what we've been talking about data and a lot of content which is in the media right now is just because of the machine learning grew up and was so popular by learning through data. But there are also other approaches of AI, such as knowledge-based AI. At the social cultural perspective, we had yesterday and today we've talked a lot about bias. So what is actually bias, the safety and reliability of the AI systems, but also what are actually the tasks of humans. And then here at the user-oriented applicational perspective, they identified two roles of the students. So the first role is of the user, right? So the teacher or the student who is using the AI technology, and then also as a creator, because at computer science education, for instance, we want to enable students to create technologies, right? So this is why we are teaching programming. We want to enable students to create with the technology. So they saw the students as the creators of AI technologies. And so at this time we decided, fair enough, there is a lot of content that the students could master and could learn about AI. So let's take this model as a primarily source of the content. So this is what the teacher, if the students need to know or are able to learn about these content areas in AI, then probably also the teachers, they need to learn these content areas of AI. So, but the thing is, the teachers, they not only need to have the content knowledge, right? They also have to have the pedagogical knowledge on how to teach the content. And Andreas talked today in the morning in the keynote. So it's kind of the teachers rely on a good developed teaching materials. So to make it easier to teach, for teachers to teach the content from this Dijkstraat triangle, we developed a set of teaching materials based on the methods that had been already successfully tested in computer science education research. And I have just here a small list of methods that we used, like for instance, the pre-activation of prior knowledge, providing different scaffolding techniques, contextualization. Today in the podium we heard from the teachers how important it is to have a context, good context for the students. We also designed the materials in a way that they enable different levels of learning. So on the one side they are low floor, so it is easy to start with the content. But they have also wide walls and high ceilings, which means they are easy to be extendable. And so if the student wants to learn more, then there are many opportunities to do so. And lastly, the teaching materials, you will see they are, some of them, they rely on the group work. So communication and cooperation was one of the concepts that we also try to foster with the materials. We gradually developed the set of unplugged and plugged teaching materials here. The unplugged, maybe you have, you remember about unplugged teaching materials that we were talking yesterday. Unplugged, it means that you are teaching computer science concepts without a computer. So we developed several unplugged teaching materials, but also plugged teaching materials, which means that you can use computer, different applications on the computer. For instance, we used flow-based programming languages such as Orange or GenAI. We used also text-based programming languages such as Python and the block-based programming languages as well. And to enable teachers to use the materials in the school setting, we built on the idea of the didactic biplane. This is actually a method where you put the teacher into the student's shoes. So where the teachers are walking the path that the students should walk. Or in other words, teacher experience the activities for themselves before applying them in their own classrooms. So how did it look like for computer science teachers? And I will talk about computer science teachers briefly, and then Till and Vaida will take over. So for computer science teachers overall, we had 11 different teacher trainings, and they all varied very much in length, and also they were conducted in different countries. involved teachers from different educational backgrounds, but they all were computer science teachers. The workshop lasted between 1.5 hours and 2.5 days, which is quite a lot. And here I will just exemplarily show how the structure looked like for a 7-hour workshop. Like what did we do in the 7-hour workshop? So if you were participating in such a 7-hour workshop, the first thing that you would receive from us would be the knowledge test. And you would receive it before the workshop. Well in advance, couple of days in advance, you would receive a knowledge test. And this test is actually thought in terms of the progress test. Like the teacher goes through the test and see, okay, this is how there were like questions on the self-assessment, but also about the technological knowledge and also the other parts of the Dijkstraat triangle. And the idea was to serve, like this test also serves a little bit as an advanced organizer. It shows what kind of content we are going to cover in the next days. Then they would come to the workshop and you would come to the workshop and you would receive some pre-questionnaires from our colleagues who were responsible for the evaluation of the teacher intervention. And then, like before, in the first half of the workshop, we would give an introduction on AI, usually using something like an AI bingo game, or also giving a short presentation about AI, and do a deep dive. And usually in this deep dive, we looked at very common AI approaches. For instance, like what is a classical AI, what is actually machine learning. And in this deep dive, the teachers used the teaching materials that were developed, tried them out, and learned about different AI technologies. Then we had a break, and after the break we focused on data, because as we have heard, data is actually the core of AI technologies, not only of machine learning technologies, but also knowledge-based technologies. And then we gave an introduction on data lifecycle, and we had also a deep dive into working with data with a computer. Usually we use the Orange 3 that you can try out today. And worked on the real-world case study. So with real-world data sets, we applied different AI methods on this data. And usually the part in the morning, like before the break, it was usually unplugged. So here you used unplugged teaching approaches here, and in the afternoon, the plugged activities. And today we have 2 activities for you that you can try out, and I marked them here green. The one is on language models that we developed, and it is an unplugged activity, and another one is on linear regression, and this is the activity plugged, so you need the orange application for that. So I will just say 2 words about each of them, and I will hand over after that to Vaida and Valentina. So in the language model activity that we developed, it's about the Grimm's fairy tales. You are developing, so you are training a language model unplugged, and then you are using the language model to create new fairy tales. And the idea behind it is actually to make this technological perspective more visible. So how does this technology work behind the scenes? It is, you need 4 people to conduct this activity. So, and it will take probably around about 20 to 40 minutes for you to conduct it. And then the second activity that we have brought with us today for you is about food quality control and bias, about the representativity of data and different types of data biases that can be inside of an AI system. And then your task is to fix the bias, to find out where the bias is and to fix the bias. And for this we use a a plugged approach. We use a teachable, the Gen AI teachable machine tool. And from the Dagstuhl triangle perspective, it covers these two perspectives, so the applicational perspective, but also the societal perspective, sociocultural perspective. Okay, so here I give the mic to Vaida to speak about the primary teachers' interventions.
Thank you, Viktoriya. So I'll talk very shortly about next group of teachers. Actually, maybe not about teachers, but you see primary school students, they are very small. And when you're trying to teach computer science overall to them, you have to focus what task to create, how to present that they would be understandable. And there was quite challenging task, especially if you are talking about such a difficult sphere like artificial intelligence, where are so much mathematics in it, and you have to present it in for the primary school students. Like Viktoriya mentioned, like 3 years ago, there was no so much hype before ChatGPT, so there were not so much research on these topics, especially primary school. So what we did, how to start learning. So this was already official project interventions, but before that, we made pilot interventions. And here we have one teacher from Druskininkai. This was the first school where we went to make those pilot interventions with the amount of some material and some unplugged activities to test and to ask feedback from teachers. Is the material suitable for such small students? For example, do they understand? Is the length of the activity suitable for them? Do they pay attention and something like that? So we made quite a few those pilot interventions, and then we collected feedback, and from that feedback we developed some like 3-4 hour seminars, because they were held in all 3 countries. In Lithuania, our partners Martin helped in Austria to make those interventions, and Viktoriya in Berlin with this material adjusted according pilot interventions feedback. And here we made in Lithuania 3 interventions. Then in Austria there were made 2 seminars with teachers. I mentioned they were not very different in length, because it was like 3-4 hours adjusted to each country regulations and some other stuff. And also we made extra intervention with pre-service primary teachers. Here you can see the map of Lithuania, just to show you information that we had the possibility in Lithuania not to make only in the capital of Lithuania, in Vilnius, but also in some smaller cities or towns, that to reflect the region and to see what the teachers and students living somewhere outside. Of course, when we were making pilot interventions, we also made in some cities near the sea and in some north, so tried to grasp as much geography as we could from Lithuania to get that feedback. And what we have learned from these interventions, of course, Lithuanian experience differs from Austria and Germany, because in Lithuania we are quite lucky, because we got new curriculum in which artificial intelligence and data literacy is already in it. And the teachers were quite motivated because of the new curriculum about this primary teachers, because of this curricula. And what else? So, mentioned Viktoriya, that we prepared, and the teachers in discussion also mentioned that the main thing what they asked, that it would be good to get prepared material with the activities, with some theoretical background, that they could, with lesson plan, that they could just take and use. Because why this is so? That primary school teachers are not computer science teachers. They do not have computer science background. And when you come with a seminar about artificial intelligence, so first you have to introduce some main descriptions or what is algorithms and other things, some introduction to the computer science before talking about artificial intelligence. And of course, what we saw that when we first started in 2021, there was something like teachers heard that there is artificial intelligence, but not were so aware about it. And when last year ChatGPT appeared, so when we made in the spring in 2023 interventions, so that hype of ChatGPT and artificial intelligence, the teachers were like more motivated, more interested because of this. So this is really helped with in our project, this coincidence. And what else? So about activities, the activities, a couple of activities like for the computer science teachers, you also could try here for the primary school children actually, what teachers were learning. But what we learned that for primary school children, the activity should be like something from 10 to 15 minutes that the children could draw their attention and then they could fully participate. Because we were like using some games from computer science teachers was from Viktoriya adapted, but they lasted something like more than one lesson, so it was not suitable for small children. And what activities you can see, so we will try two activities. The first on the top of the slide, so there would be some card game like Ligretto cards. We developed our own, and one game with buttons. And also below you can see the card is from Bebra's task, so there are also those short activities, and you yesterday saw also on one of the poster was presented that there are some Bebra's tasks, and Valentina mentioned who also focus on data or artificial intelligence. And like you know, children are participating in Bebra's challenge, so they are familiar with the environment, so it's also very good to incorporate those tasks. And now the creators of the task also focusing more on artificial intelligence to create with data tasks, so this one of the material which could be used for the teaching. So thank you, and I will welcome Till about STEM teachers.
Yeah, thanks, Vaida. STEM teachers, yeah, let's come back to the original question that Viktoriya put out. What should the teachers learn? And to be more specifically, it's about STEAM teachers, and yeah, STEAM is like an abbreviation, and we decided in our project that we want to address, of course, science and technology, like physics, chemistry, biology, but also the arts teachers, to be creative with AI, math teachers, and we even had a broader focus also on the languages subjects. Yeah, so the idea was to design a workshop or lessons that are suitable for like any teacher who does not know so much about AI and data science. Yeah, and that's what we want to bring to them, some knowledge about AI and data literacy. Here's a long-promised Venn diagram what we heard that computer scientists are so proud of, and that's a model of teaching competencies of knowledge. First, we have on the upper side the technological knowledge, and yeah, it's here. And in our case, we want to train the teachers in using AI and data literacy to have this as a tool in their subjects. Their subjects here on the content knowledge side, these are biology, languages, whatever. And they will have to teach it to the students, so we also need to find activities that they can use for in their lessons. Yeah, and to lay it out in another way, we want to make it specifically for one example, and the example that we will introduce, it's also one activity that you can try out. It's an activity about sea life, and this is then biology. We use linear regression as the technical knowledge that that we introduce to the teachers as multiple linear regression. It's a machine learning method that they can apply then in this activity to some data from marine life. And we used Orange 3, which is a data science tool, which it's a visual tool. They can set up workflows, data workflows in a visual way without defining the algorithm. Yeah, and at the end, this is the center, which combines all three aspects of technology, of contents, and of pedagogy. This is an activity that we laid out. It's a case study, and there we chose another animal, not the whale. We chose a sea snail, an abalone, as the animal that is the star of the activity, so to say. Yeah, so what we finally have, this three aspects, and then it finally comes into this activity, the real-world case study, the context that we can offer the students. Yeah, how old is the abalone? That's a question that we're gonna answer in the activity. You can try it out on one table. You see below the visual language of the Orange 3 tool. Like this is one data workflow that you can drag and drop and arrange the widgets. So at the end, you can find out how old the abalone is. Yeah, another activity that we tried out with team teachers on their request. It's not so much funded in technological knowledge, it's more the application side of the DAX2 triangle. Because when ChatGPT arrived, everybody was interested how to use it, and in our workshops we gave a platform for the teachers to share the prompts that they use and to try it out with Schul-KI. That's a data privacy GDPR conform tool. They are based in Leipzig. And basically they're using language models like GPT, but it's anonymized on their server, so it's possible to use it at schools, and it also supports to use it without an account for the students, which is important. And yeah, that's the tool of our choice that we gave the teachers to play around with prompts and to get more prompting techniques. Yeah, retrospective. The STEAM teacher trainings we started only less than a year ago in summer or late spring 2023. We had 2 trainings in both in Austria and Lithuania, and then some more trainings in Germany, including one weekend workshop a few weeks ago in Meißen. Yeah, this is something especially that we prepared for the online participants. The Gramm activity that Viktoriya talked about briefly, where you can train a language model. We prepared this in a replugged way, so it's not unplugged, it's replugged, it's brought back to the virtual sphere. Yeah, and I invite all the online participants to collaborate on a Miro board, and I think we will start in about 10 minutes. And I think there's a special room, a Zoom room that was prepared for this. Yeah, the assistants are nodding. Yeah, and there you can train this model, create a graph like this, and at the end, sentences come out that may have or not have a sense. Yeah, so far from the STEAM teachers, and now I hand back over to Viktoriya to tell something about the activities here in the room.
Right, so we will now have a pause of 10 minutes, and then you are very welcome to come back and sit onto one of these 4 chairs. So we will do a 3 rounds, so you will be able to try out 3 different activities. The station number 1, it will be about language models, and it will take you approximately 20 to 40 minutes. I mean, probably it will, if you want to fully experience the activity, then you will probably need 40 minutes. If you want to just take a quick look, 20 minutes would be enough. So we will have at the end 3 rounds, every round 20 minutes. So you can decide which activity to take. So the station 1 will be about the large language models, or about language models. The station 2 will be around Abalone and Orange 3, so you need a laptop and the installed Orange 3 software, as we asked in the preparation email to the summit. The station number 3, it will take you about approximately 20 minutes, and it's on the food quality control. And station number 4, it will take you also about approximately 20 minutes. It is primary teaching materials, Allegretto cards, and the button game. So you can decide how you are going to combine these different materials. Every 20 minutes, I will do a loud noise, something like wee 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 wee, and then you are allowed to change. Okay. But for now, you can have a 10 minutes break. So let's see each other in 10 minutes. It means 10 before 2, okay? So 10 before 2, we will start at the tables. Okay.
So I hope you had a nice workshop online and on site. And to conclude this workshop session, I would like to, first of all, probably it's important to know for you that you can ask your questions after the following talk, because we will have a joint Q&A here with all the speakers from the workshop and from the following talk. And for this talk, I would really like to welcome our speaker who is working for the Department of Computer Science at the Chair for Complex Multimedia Application Architectures at the University of Potsdam. Welcome, Martin Reger.
Test, okay. Was the same for both levels, okay. Yeah, hi from me. Welcome to the last workshop of the TrainDL Summit. I would like to talk today about the evaluation results, and just sending out greetings from my colleague Genia that worked with me on the evaluation, who can't unfortunately be here. So I do this alone, but I send you her greetings. Yeah, what I want to talk about is the evaluation results. That just like I said, we gathered the key evaluation results. So these are not all the results that we gathered, but I think most important for us, and maybe also most important for you or interesting, are the challenges that the teachers faced and they reported in the interviews and in our surveys. And also maybe we can talk about the limitations of the evaluation, if we have time, and also speak about future questions. And at the end, just like Mike said, we can do a Q&A together with the other colleagues from TrainDL. So what do you see here? This is an interesting graphic. It's like twofold. The left side is how we did go about in the evaluation. This is the action research methodology. You see here, the first point above is the policy cluster. So what we did do is we designed the trainings in accordance to the policy cluster and the recommendations, also the policy design workshops that we held in the project, and the trainings were designed. We conducted the trainings, and also the trainings were evaluated, and this is like a cycle, so we can say that the trainings results always inform the other cycles, and this is like a not ongoing, never ending cycle, but an ongoing cycle. And so this is the approach that we took. And on the right side, you see that we evaluated different kinds of feedback from the teachers. We did have, for example, we evaluated what their reaction to the training was. This would encompass, for example, what did they feel about the training, and also what did they learn in the second step about the training, and also what was most difficult actually was to evaluate their behavior, because we had problems. You see here, we did some follow-up questions after initial intervention, but we really had the problem in the follow-up interventions or surveys that we collect enough data, so the response rates were very low. So what we did do is we questioned in interviews questions like, do you plan to integrate these topics? So these questions acted like a proxy for the actual integration, which we could not really exactly cover in our evaluation. Here you see an overview of the training, some interesting numbers. I think the most important numbers you see on the bottom here, that we had in total about 400 teachers that we did service with, and most of them coming from the CS field, meaning computer science field, and 139 teachers were from the STEAM field, and 89 from the primary complex. And we did have round about 75% that actually participated in training. There were some data loss, or so out of logistical reasons we could not ask anybody, but these participated in the trainings, and we also did interviews with about over 100 persons. So this is quite a good number, I think. Here you see the most frequent subjects of the teachers that they gave us info about. I think most important when you see this graph is to keep in mind that not all teachers have one subject, but in fact they can teach more than 2 subjects. And you see here for the computer science group, of course this is actually the computer science teachers consisting of 100% computer science teachers, but the second place of the most subject that they also teach is mathematics. And you see when you have a look on the STEAM and primary groups that mathematics is also a subject that was often taught by the teachers that did participate in our trainings, and also biology and languages was also kind of often represented. Yeah, now we come to the training feedback. So how did the participants actually experience the training, and what feedback did they give us? And we focus only on in-service teacher trainings or in-service teachers, because the pre-service teachers we did not conduct interviews with, so we excluded them for the purpose of this presentation. So what you see here in the positive feedback is that 90% of the participants felt that they could recommend the trainings to the colleagues. And on the whole, this was kind of an agreement between all groups. They said these trainings were really a valuable introduction to the topics of DL and AI. And what was particularly of interest for them, or they find really this was really very well regarded, was that they really liked the exercises that they could try out, get the hands-on approach, and make the kind of exercises that also would be done later in the classroom by the students. It's called a didactic biplane. It's like the translation for didaktischer Doppeldecker in German. And what they also really liked is that we provided them with materials that they can take home with, they can look up, engage with, and also could potentially use later in their classroom. So this is the first graph here for statistics purposes. You see here that we immediately after the training we asked the participants how they would rate the societal importance of AI and DL for integrating them in the framework curriculum. And what do you see here? This is like a box plot. I don't know who heard of this term, or how many of you did heard about the term, but I will shortly explain what it means. This box here represents 50% of the data in the distribution, the 50% in the middle of the distribution. So this right here is the median, it's called. It's the central value, meaning when you would list all values of one distribution, it's exactly in the middle of this distribution. And you see here on the right side, these are the values that are the 25%, the rest of the values that would lie above the central value. And of course, this then would mean 25% of the values would be represented by the left side that lie under the central value. So what this does tell us is basically distribution for the items or the questions we asked, and we also see what was the value in the middle, and this is really interesting for us also concerning the spread or the range of the answers that were given to us. So what do you see here? You see the question, societal importance to integrate into curriculum. The agreement from a scale of 1 to 6. 6 meaning, of course, high, and 1 meaning very low. And you see here that for all groups, the central value, except for CS, is 5. For CS is 6, meaning that the societal relevance of AI was rated the highest among CS teachers. And you see also that the spread is relatively low, meaning that the boxes really are larger for the other groups, meaning that this really is the most agreement on this questions regarding AI and in the CS group, comparing it to the other groups also. Yeah, and another graph. Here you see the value of teaching. It's basically the same result on the surface, at least. Agreement is relatively high for all groups, but you see actually here the value, the central value for primary, for DL is the highest. So this may become as a surprise. Yeah, but other than that, it's a high agreement for the question. Yeah, despite these kind of high approvals, we led interviews with the teachers, and what we experienced was some kind of mirrored already also in the TrainDL Summit that we have until now, meaning that there's really a lot of room for improvement. On the first is that they said, yeah, it was a valuable introduction for these kind of topics, but there would still be need for more training, because what did they get? They got basic knowledge, but they want to have more knowledge, more deeper knowledge. So what they did propose to us was a kind of ideas how you could go about that. So they told us about different training formats, and these different kind of training formats are related to different criteria. Sounds mysterious, but I will explain later. And the last point is the trainings were often considered too short. And of course, this is something that is connected to the first point. They got basic knowledge, but in order to get deeper knowledge, of course, they would need trainings to be longer. Yeah, to that point. I wish the training has lasted longer. This is very interesting graphic, I think, because what do you see here? It's one of the boxes in the STEAM column is very much tilted to the left. And what does this mean? We had 3 formats, basically, more formats, but they could be clustered into 3 different groups. The first group is 1.5 to 4 hours, like a short format. The 7 hours is like a middle format, one single day. And the 2.5 days are really long workshops. And what the STEAM teachers told us with their answers is that 2.5 is enough for them. They wouldn't want more. So this is not exactly the opposite, but it is different for CS teachers, because what they told us is the longer the training is, the more they want knowledge. So more is more for them. And for primary, we didn't test really other formats than short formats. We see here they would say for the short formats, I wish the training had lasted longer, but we do not know if the same or a similar distribution would occur if we had longer trainings with them. But we hadn't tried this out with primary teachers. Yeah, and also for STEAM, what's kind of interesting is that you see the trend of not wanting longer workshops already appears here in the 7-hour column. So this is like here in this skewing in the direction of not wanting more the longer the training lasts. Now to the learning part. We look at the teachers, or look at what the teachers have learned. So we have an item or a question called how to use DL in a classroom. What is interesting about this question is that other than the other questions that we shown, or that I shown till now, it's a pre-post comparison. So you see here for DL, and the blue box represents pre, and the orange box represents post-training. So you see now that for all groups, basically, there is an increasement. An increasement in before and after, meaning that they agree to this question more after the training. And we asked the same question about AI. And here it is interesting that the ranges for primary, meaning that they really have a big leap here in this column. And CS teachers, interestingly, did say that they did not know exactly how to, or not so much know how to use AI in the classroom. It really leaped big here, because here's the median 5 and here on before us 3, so a big increase here. But basically both these questions have increases for all groups. Yeah, and to the point of competences and application, you just tested activities, and to the point of activities, we also found out which activities are rated the most or the most suitable by the teachers for the application in the classroom. So in total we had 27 activities. Important to know is that not all activities were introduced to all teachers, because we have different training formats. So not all were exposed to the Grimm's fairy tale that you just did. But this was really a very high rated exercise, Grimm's fairy tales. I think for the other exercises I will not read out. Maybe you can ask later if you're interested. Yeah. And more activities, something also that came up often in the interviews was what was interesting, I think, for all groups, also for CS teachers. They all thought the unplugged activities are really a good approach to introduce children, students to this kind of topics, because it is a very good for introduction of basic concepts through an playful way, I would say, especially for the primary level. It's a good way to make way for the concepts. And Orange Dry, on the other hand, also across all the groups that we spoke with, said that Orange 3 is really challenging and is really perceived as a high-level tool, although some teachers really saw the potential, and it's said that it's a good way of visualizing working with data. So definitely the potential is be seen, but apparently the teachers thought that it's very hard to use for the first time. Yeah, and also point that came up today is the last point, the matter of black boxes. So what we get info about was that the teachers really felt that AI itself and also the exercises connected to it, there were black boxes for them. Sometimes they did not understand, or they did not understand, or they did understand, but feared that the students wouldn't understand it maybe, and therefore there would be needed a better approach or a better solution for this kind of problem, or framed as a problem, the black box problem. Yeah, and yeah, now we come to the third point where I said that is actually was hard for us to evaluate the ability or the actual integration of the LNTI in the classroom. Here you see like a proxy. We asked, do you have enough competences to teach that content in class? Also we asked that after the training. And what is interesting about this graph is that primary and STEAM reported that they felt relatively confident. You see here this value is above the middle ground, or middle value of 3.5. And STEAM did also feel that way when you see the value in the middle, but all the other values below that were really, well, the distribution is really skewed into the left side, meaning that there would be room for improvement. But not only there, I think when you see all the graphs together, you would say, yeah, there's improvement for all the groups, so that they feel they really have enough competence and to feel sure about integrating the topics into their class. Yeah, and now I think one of the most most interesting points are the challenges that were reported for the teachers. Just to say, this is all something that the teachers told us. It's not some solutions that we thought about. This really came up in the interviews. And it's also mirrored in the talks and discussions we have in the TrainDL Summit, I think, especially for the first point, because workload is high. We spoke about that. This is kind of a disparity going on here. On the one side, teachers often said us single trainings are not enough. But on the other side, they also said our workload is very high. We have very few time to not just to visit trainings or participate in trainings, but also in their daily work life. And so it is hard for them to find time for participate in trainings. Solution, not an easy solution, I think, but I think we can here now see that different formats are proposed for this kind of problem, and I spoke about it earlier. I can go a bit deeper now into it. Series-based training was proposed, but I think this is more like not regarding the time problem, but more like targeted at an incentive level, because trainers often said that they would like to have space between the trainings, and not like shortly after that one training or a longer training, but they want really to have time between the trainings to test out what did they actually learn, and I can test it out in my class, and maybe I can take that experience in the next training, speak about that, we can evaluate it and work further on. So a series of trainings is an idea that really was forwarded to a lot of times to us. The online training is more like it's more regarded or targeted at the time problem, because you can really have short online trainings. It was proposed to us maybe 60 minutes, and there you can really have a deep dive into topics, really concentrated learning about one tool maybe, and also the teachers would be free of logistical or time-wise restrictions. And this goes also for the hybrid format. It's like kind of goes in the same direction of saving time, I think, because sometimes you say when you visit a training, some parts you could have done without participating in person or on site. So you could think about to outsource some of the content from trainings, make them as an online format, and the activities that really require on site, you make them on site in the training itself. And the flipped classroom trainings was also something that came up yesterday, I think. The flipped classroom approach would be a reverse of the training approach, so that you give basically the teachers homework, they can learn or experience themselves at home and bring what they have learned and worked with in the training, and then you can work with it in the training and go on about that. So you also have a different approach and save time. So big one here, technical infrastructure and resources was brought often up, and yeah, the teachers reported that they often had insufficient technical infrastructure to work with, like no wireless LAN, no computers, software is not installed, nobody, technical administrator is not there, or not there only one day in a week. And so this would be an easy solution, also on the surface level, easy provide infrastructure means, but also requires money and political will. A big one also, framework curriculum integration. Here we asked about specifically if they would support this, and all teachers said yes, we will support it, but of course it is not enough if it just only is in a framework curriculum. You also need other factors to consider, like for example that the framework curricula are overloaded. So one solution would be reprioritizing the curriculum. Different methods here you could use. Was not something that was brought up in interviews, but You can synergize. You can separate. You can maybe exclude something. Different ways to go on about that. Feasibility of new content should be assured. Yeah, this is also something what also came up already in the TrainDL Summit. It would be good really to have materials that not only have one aspect, but really are well structured and for one lesson or maybe a series of lessons with all the things that you need to teach that, meaning not only the activities but also the context knowledge, the theoretical background. Today it came up about a problem, how you, it's a problem to write a task or to assess the pupils, so this could be also something that is integrated or alluded to in these plans. And the last, teachers should be sufficiently trained. I think this is one point that came up quite often in this presentation also. And it's more trainings on the one side, but also it is paramount to integrate this content into the teacher education at the university level, just not starting in the now enrolled teachers, but also really try to integrate it in the first education for the profession of the teacher. So, and this is one of the last slides. It's also alluded to challenges, but this time it is just the challenges for each of the target groups. We heard today about the big wish for CS to be a mandatory subject, and this was something that was brought up quite often by CS teachers. They say we want to make CS a compulsory topic subject, and also they reported there are too few classroom hours in the now ongoing teaching of CS, and DL and AI are not taught in non-CS subjects. Yes, solution would be make them mandatory. They didn't really tell us how, but how you fabricate the will for that, but you have to make that mandatory. But one solution would also be make mandatory DL and AI components if you can't do, or if it's impossible for the start to make it compulsory as a subject, start with some components to make it compulsory and go on from there. For STEAM and primary, I think the main thing is that they really did not often, or they did sometimes see the linkage between the subject and the LNTI, but not always. So it is hard for them to really have an incentive then if they don't see the use of the topics in their subject. Why would they use that? Then the one solution would be make these linkages more visible. So try to make the linkages apparent, and you can do that, for example, in the materials that you produce, and you can do that in the way that you make for each subject an individualized plan extra for that subject with specific approaches and applications. Yeah, and for the primary, there was not so much about exclusive primary challenges, but it was reported to us that large classes can be a problem, and there's in the large classes no one that helps the teacher to disseminate the knowledge to the students. So, but no solution here to be found in the interviews for us. Yeah, and now I just want to summarize. How many? Okay, now just to summarize what I just said. I just read out because it's condensed. So as summary, CS STEAM primary would be a valuable introduction for teaching, and They agree on the societal importance, and also it brings added value to the students, but there would be more clarity be needed among the educators regarding the role of DL and AI, because we saw there is disparity in the results for DL and AI, and that speaks for the non-visibility of the link between DL and AI, and that should be made clearer then, therefore. For Siemens, yes, teachers, they rated Grimm's activities as one of the most suitable activities, and Orange 3 is a complex tool and received mixed feedback. Single trainings are not sufficient for the integration of DL and AI topics into the teaching, and the teachers emphasize the need to incorporate DL and AI into the CS framework curriculum, yet merely adding DL and AI to the curriculums won't ensure that teachers are immediately adept at teaching them, and this underscores the need for teacher training. Yeah, and so we end here, and we can now discuss.
So thank you very much, Martin, for your presentation. Please take a seat, and please come to the stage, Valentina, Vaida, and Viktoriya, for the Q&A of the workshop. So you, dear audience on site and online, will now have the chance to ask them your questions about the workshop. Yeah, until, of course, sorry. Please ask them anything you would like to comment on, any questions you might have. The stage is yours.
Workshops maybe was too hard to you, that you do not have questions.
Sorry, just break the stalemate. Can you hear me? Yeah? Okay. So let's fill the void. If we could just go back to the other slide, the one about the limits of evaluation.
This here?
No, the other one. No, ahead. Forward. The last one. The last one. The one that had limits of evaluation. Well, anyhow, you had there an item about yes, that one. The culturally diverse and the difference in country contexts and educational systems. So one thing that connects with the observations by the teachers is the limits in the curriculum and the limits on integrating DL and AI into their subjects. So maybe one activity that you could develop further, or that you could set some guidelines for in the materials, is to compare what you are proposing in terms of teaching methods, instruments, and contents, and guide teachers to reflect on the plan of activities they have to develop throughout the school year, but also what is their school identity, the typology, like whether they are vocational, where they are simply propedeutic, and what is their mission and purpose in terms of the community in which they are located. For instance, urban, rural, whether it's ethnically diverse, or whether it's dedicated to some minority, and integrate these DL AI topics to these core missions and core themes that are important to the school communities and that sometimes are even registered in a document that is this identity, vision, mission, plan for each institution.
Yeah,
Thank you.
I would like to say about that, thank you. in fact, it speaks even more to one of the things that we said here on the second point, because you said include the community and include other actors, because in TrainDL we had the limitation. It was the nature of the project that we only asked teachers. So our proposal was to look also on other target groups, and this would include, like you said, communities and schools, and also I think make sure that the practices are best practices, that they are well suited, and this is something that, of course, this project did not do, or we could not do, and was not our aim, but really make scientific funding, well-fund practices, and make sure that they are best practices.
Thank you for the presentation. I have also maybe a critical question to the limitations of the evaluation. Or the threats to validity. Like, I mean, in service teacher training, it's always the problem how you assess if the teacher really benefited from the training. But I think regards to social desirability, when you measure with a Likert scale from 1 to 6, I think it's not so valid. What do you say to that, or maybe what is the future perspective to assess data literacy and AI competencies, or their perceived competencies of the teachers for another in-service teacher training?
Yeah, it's always a problem that the self-assessment doesn't is not in line with the real situations. So what I would propose for that would be also something for future projects, measure the impact, actually, and not only the impact on the teacher side, but also on the student side. So this would be a future question.
And maybe I can add on that, because actually at the beginning of the project we were exactly interested in that, like how much did the teacher learn, like how much actual knowledge did they gain out of the workshop, right? And so at the beginning of the project, we developed actually a questionnaire, knowledge test. Like, do you remember when I was introducing like this 7 hours structure, all teachers before the workshop, they received a questionnaire, like a knowledge test, where they could like click through the questions and try to answer them and see, this is something that I will learn in the workshop. And there we also had self-assessment questions. And when we evaluated this, we found out that actually the self-assessment does not correspond with actual knowledge. So the teachers, they might assess, they might say, oh, actually I'm pretty good, and the knowledge test says actually no, and then the vice versa. And we tried to find like this. Like why this is the case? So we try to look into the prior research, and actually it's quite often that there are like this misunderstanding, misconception of my subject, like subjective knowledge like that I have, and the actual factual knowledge that I have. The problem with the assessment of the factual knowledge is actually that in order to develop a very good knowledge test, it's a lot of work, and I think it's a PhD on itself. And what we are doing right now, it's because we didn't show the results for the knowledge test and the knowledge items, because we did it like we run the first phase, but now we have to check to verify like the validity of the question, the reliability, and we are still developing, like we're still working on this test, and it will, like we will continue working even when the TrainDL project has ended. We are still working now with the people who are experts in developing such tests, so that we can verify the validity of the items and things like that. So yeah, I hope in the future, in a couple of months, maybe there will be like one version that we can release into the world that the other people can use. And our dream is, our vision actually, to have like this test online somewhere where different people can take the test, try to assess, and then work through the materials, and then take tests again in terms of and see in terms of a progress, this is what I have really learned. So yeah, we're still on that, and it's actually a huge issue. Like measuring the actual knowledge in CS classes. Yeah. There is one online question, right? Okay.
So, okay, thank you. Did you follow any particular instructional design framework for any of the activities? Or like, how did you, if you didn't follow any particular instructional design framework, how did you design it? What type of framework theories came to mind to organize the activities themselves?
So you mean something like the semantic wave or the constructionist approaches, something like that?
Yeah, I was thinking, like, for example, I don't know, there's this ADDIE model, which is like analyze and design, more like that, but any type of design system that you used.
Yeah, obviously. So we tried different approaches, like use, modify, create cycle, which is quite often used, and also different principles of the constructionism teaching approaches, like wide wall, like low floor, wide walls, and high ceilings, and design for designers, things like that. But also different scaffolding strategies, so that you are first working through the teaching material, which is very structured, and then it's kind of opens and gives the student the opportunity to work, for instance, with another data set, or maybe try out different algorithms, things like that. So we were trying to align, to make it in a constructionist way, but I can say my experience is that it is a very complex topic, and yesterday we were also discussing in the evening that it's difficult to make it kind of open, so that the people, so that the students, so that the teachers I feel like that they can really create with this technology. Like if you're thinking of maybe in terms of the Bloom's taxonomy, right? The highest level of Bloom's taxonomy is to create, but first you need the understanding. So you build up until you can create something, and it's super difficult to reach this create stage actually then, because you have to understand how the data is working, how to prepare the data, how to clean the data. So in order to create really AI applications in a meaningful way, in an effective way, there is a lot of things that need to be done, a lot of scaffolding, a lot of competencies that need to be built before you can reach like this, this create stage. So and we continue working on that. So next year, because I am continuing also working on that. Next year we will also try these materials and also other things with the school students. So we have one teacher in informatics and also in mathematics, where we will try this out with school students together with the teachers, and then evaluate it as well and see how far we come.
Thank you.
And also maybe I would like to add, because it's my also question for myself also, do we need to focus only on AI competencies for teacher, for example, competencies, or we need more broader? You know, today was mentioned DICOM, they mentioned that there's selfie for teachers, that it's like 36, I think, questions that teacher can evaluate their competencies, but in very broad sense. But maybe we need something like computer science or modern computer science evaluation, that we can, as teachers, we can evaluate and see what gaps we have, and maybe AI is one of part, or data literacy, because it's maybe in very narrow. When you are talking about knowledge test, it's very good, it's deep, it's different. But when we are talking about competencies, we need something. Especially in computer science, and it is really complex problems that doctoral students are solving, and Vaida is doctoral student who also focus on evaluation in computational thinking, and need to search some models, go to computational thinking or in computer science to help teachers, to help us all just to evaluate, to assess what we knew, what we do not know, what we wanted to improve. I think that it's a big question.
I maybe answer more that to question how we formed the format of the seminar and activities. I shortly presented, but like for primary, we have some theoretical part where we actually made like more than 10 piloting seminars, and when then we collected the feedback from the teachers, what works, what they think, when they think of their student, those primary students, what could work, what could be useful, understandable. Because, for example, I had one seminar with second graders, it was 2 classes. So one activity, yeah, it was okay for them, but like that, what I mentioned earlier, this time limit when they can pay attention. They are very motivated, they are doing those activities, but in a couple of minutes they have to finish and they draw away their attention of that task. So a lot parts made from the practical experiments, how to form those seminars and what activities to use from primary school. Thanks.
One last question from the chat.
Yes. What was the reaction of the participants of the live workshops? What do they think about the usability of the materials?
Mixed. There was mixed reactions because for some we actually can't really have insight in if they actually used it, because we couldn't catch, I would say, all the teachers 6 months after the intervention. But the initial reaction was that they were thankful, but they also wished for more and more in depth and more structured and more laid out material for them. But they were really thankful for getting the opportunity to get something in the hand and take home with.
Then thank you very much for your answers. Thank you very much for your questions. Let's applaud to the speakers. And you can take your seats again. Thank you. And
sorry.
No problem, because this was our last program slot. The summit is almost, this is it for now, actually. So I would like to ask all of you if there's some question left or some comment you would like to say, because this is the last chance for now. No? Okay, good. So, if there's no more questions for now, I would like to say thank you for this wonderful summit, for the exciting 2 days we had together, for all your discussions. And we heard so many different voices. We heard teachers, we heard students, we heard policymakers. We had so many different topics about what's being done, about what the future holds. And we would like to discuss these topics also further with you, so please stay in touch with us. You can always email us at traindl.gi.de, traindl@gi.de. And we will also upload the teaching materials. I will have to show you the other presentation with the link, because they will be uploaded this evening. Here it is. Under this link you will find the teaching materials. So please use them and give us your feedback, and there's also our email address. Just email us in case you want to discuss something further, or you have any other ideas for common projects or joint topics you would like to discuss with us. And yeah, it's also clear that such an event wouldn't have been possible without the help of many, many people. And we would like to thank many people. And I have prepared a list for that. And I would like to ask you to bear with me because I will read that list. And please applaud in the end and not after every name, because then as much people contributed, we would be here at 6 probably. So a big thank you goes to the teachers who took part in the workshop, because you had so much extra work and you gave so much valuable feedback, and nothing would have happened without you. Then, thanks to the public authorities who took part in the policy workshops and who contributed their expertise and their experience. It's super valuable for us and for education when your organizations open up and develop topics together with science and schools. So thank you for doing that with us. Thank you also to the public authorities that were part of the consortium. We know it's not always easy to understand the other's perspective, but we think it was worth it. Thanks to the advisory board. Ira Diethelm, Fredrik Heinz, Olga Kurasova, Enrico Nardelli, Wolfgang Pre, Matti Tedre, Jan Fahrenhold, Pat Yong Pradit, Kate Farrell, and Bernadette Spieler, for your expertise and for your advice with which you have tirelessly supported this project. Thanks also again to the European Education and Culture Executive Agency for the generous financial support, and to the Erasmus Plus program for co-funding. We really appreciate your interest in the project. That is really special, and we were delighted that Georgi Dimitrov spoke at the summit today and that he was coming to Berlin to support this project on a grassroots level. Thanks also to the TrainDL Consortium, to the Freie Universität Berlin, to the University of Potsdam, to the University of Vilnius, to the Austrian Computer Society, and to the German Informatics Society. An Erasmus Plus project like this, and for many of us it was the first one, is not an easy ride. And thank you for the group effort and the great cooperation. And then I would like to thank all of those who made this summit happen. Our Tuesday morning task force, I guess I will miss it, especially Martin Kandelhofer, Martin Reger, Evgenia Samoilova, and Til Zoppke. You were always there, Tuesday at 8:30. And then my colleagues at the German Informatics Society, first and foremost Rika Bach, you really did a fantastic job. And also Caroline Henze, Maja Denisova, Daniel Krupka, Christina Sterz, Lasse Scherbel and Edgar Wuttig, and our project lead Anna-Sara Liegfeld. And, of course, the great team at our venue, Jenny, who runs all the technical stuff literally, and also Nico for answering so many questions and making sure everything ran smoothly. And of course, our final thanks go to you, dear speakers, and dear poster presenters, and dear audience online and on site, because this summit couldn't have happened without you. So once again, thanks, and have a safe journey home.